Right, I think we're ready to get started. Is that okay, Yuval?
Absolutely. Whenever you're ready.
All right, just request anybody who's going to be involved in the first session to have their cameras on. We're going to get started with just a brief introduction to the showcase. Anybody who's been here before, I'll tell you just a little bit the layout. We're going to get started with a brief presentation on our end. It should be more than, I'd say, 8-9 minutes. And then we're going to get started with our first pitch event. Also, we're going to reserve a little bit of time just briefly for the panelists to introduce themselves, and we'll get right started. So, Yuval, if you could put up the presentation.
Yeah.
So, just a little brief intro. So, we're at the Industry 4.0 Deep Tech Showcase. Each showcase, we have a different industry focus, and obviously we're excited to have Industry 4.0 companies and also panelists that are invest or contract or interested in the Industry 4.0 as a whole, but also general technology. But briefly, before we get fully into it, Deep Tech Showcase is basically a network which connects public sector corporations and investors with the innovative deep tech startups themselves. Our mission is pretty simple, though it's complex to actually execute. Our mission is to advance innovative small businesses and their solutions together with investors, corporations, and federal. Today, we also open to city and state agencies in order to accomplish this goal. So essentially what we are, the showcase is a business community for deep tech, whether it be startups that are innovating and creating the next generation of deep technologies, as well as the stakeholders. And we define stakeholders as those that open the door and allow for deep tech innovations to make it to market. So why deep tech? Why is our fixation on deep technologies? Well, two real life applications. One is we have the unsolved challenges of today, and we also have the challenges that have not yet come up, but are going to come up, because as technologies develop and advance, so do the challenges we face. And so deep technologies really hold the secret at how to unlock those problems and turn them into challenges that are solvable. And really, without the partnerships between the stakeholders and the innovators, we find this is a daunting task. So why the showcase? Why? It should be simple. You would think you have people who are interested from a stakeholder perspective, whether it's government, whether it's tech scouts from major corporations, or whether it's investors. It should be easy to find deep tech startups. However, the gate theory says as follows. There is a lot of noise out there, and as a result, the gates are blocked, and companies and stakeholders have a challenge of meeting. Because these innovators are struggling to open these doors, or why are they starting to open those doors, is because the tech is often as good as the UX design is bad. In other words, their technology doesn't have the great marketing pop that maybe another company does. However, the technology itself is innovative, it is interesting, and it should be taken great pains and interest from stakeholder community. So as a result, two sides need to find a way to connect, and we believe that the Deep Tech Showcase addresses that concern. So our startups, to define them, are developing deep tech, which is kind of a ubiquitous term. It's kind of hard to define, but pioneer tech, which is patentable technology that is working to solve, like I said, today's challenges or tomorrow's challenges. But it's also dual use technology, meaning that it has application not just in the private sector, but also within the public sector. The last is that the startups that are participating in the showcase have won government funding for their R&D. I mentioned this just briefly before. Our stakeholders, as we defined, are those that open the door for deep tech technology to reach market. And we loosely define them into three segments: public sector, major corporation tech scouts, and of course, investors interested in deep technology. We help companies with three main areas. The first is getting ready to pitch at events like this, but also to approach companies through other channels. Through guided introductions, which is, the truth is, we don't just represent the companies, we also represent the stakeholders. And so it's important for the stakeholders to get a look at the companies before they get an introduction, so as to save time, save interest, so that when there is an introduction made, there's a high level of interest already established prior to that introduction happening. And the last is through the events themselves, like today's event. So we run monthly events. You can go to the next slide already, Yuval. We've run 4 of such this year, and this is our 5th event focused on Industry 4.0, as you see in the far left corner there. And we have many events coming up for the rest of the year: smart cities, energy, autonomous systems, materials, semiconductors, aerospace and defense, space and AI, software, and we're also going to have a summit, please God, at the start of the new year, 2022. Next showcase coming up is focused on smart cities. It's on June 17th. It'll be starting at 1:00 p.m. Eastern, and there will be 3 sessions. According to our tradition, there is always an open topic followed by 2 industry specific. The first session is going to be focused on open topic, like I said, followed by connectivity, and then by mobility. So let's take a look at today's panelists as well as our companies. So starting off with the open topic, we're joined by Ryan Hatcher from Lockheed Martin, Dana Jensen from the United States Air Force, from USACO, Hahn, from Deloitte Consulting, Jacob Hahn, and from MFV, or Mobile Foundation Ventures, Karthi Madasamy. The first set of companies pitching are Turing Micro, Dot Incorporation, Infinite Enzymes, Argus Technologies, and 8i. After the open topic, we're moving out within the industry events themselves. We're focused on the brain, or the smart factory session. And here we're joined by Ted Machuba from United States Army Futures Command, Karthi Madasamy, also Jacob Hahn, Todd Stavish, Rose Chen from Wesco Distribution, Destry Grogan from Army Futures Command, from Worldwide Tech Services, Mark Bodner, from Siemens Digital Industry Software, Charles Crofer, and from the city of New York, Jen Nabarakawa. Companies pitching at the Smart Factory are Deep North, Silicon Core Technology, Franz, Phonetics, and Market Advantage, also known as Greenwich HR. And to end our day, we have the bronze session, where we're going to get into advanced manufacturing, 3D printing, and other the more heavy parts of the Industry 4.0, joined by Owen Meyer from Okai Network, Hanko from USACO, from Army Futures Command, Tim Crane, from GC International, it's Tina Tasakowag, from Autodesk, it's Vanessa Sigurdsson, from Shimizu Corporation, Shuntaro Kano, from Hexel Corporation, Robert Yancey, and from Vingia Venture, Matthew Cohen. And the companies pitching at this 3rd session are ChemCubed, HCS Global, Peanut Robotics, Newborough, and Aqua Metals Incorporated. Okay, we're going to get started. And we're actually going to open it up to our panelists just for a moment. Panelists, could you please introduce yourselves and maybe just talk about something that you're looking forward to seeing today? What would surprise you? A technology that would solve a pain point of yours, or technology that you'd like to see and make a potential investment or engage with this business. So let's start around the horn. Hanko from USACO.
Sure, thank you. First of all, such a pleasure to be here. Thanks for the invitation. This is not the first time for me, and I found this your event is very useful, productive. I really appreciate it. What I'm looking for, I'm company that I founded, USACO Group. We're an international investment company. Our pain point is that a lot of times, just like Josh, he just the point there. A lot of times when we work with the governmental entities, and then as well as educational institutions, we found that there is a kind of the gap actually between the communication. Okay, so each industry don't know how to find the right startups and organizations and technologies. Okay, so I'm here to fill the gap and bridge the gap back in a way. And then we are also international investor would like to invest as well. Thank you.
Great, wonderful. What's a technology though that you would, if you saw it, you would jump out of your seat and say, I'm investing in that today?
Well, focusing on industrial technology with the robotics and AI, that's what I'd like to see today.
Wonderful, wonderful. How about Ryan Hatcher from Lockheed Martin?
Yeah, sure thing. Thanks for inviting me. This is a great honor to be part of this panel. Yeah, so representing Lockheed, many pain points. They sort of span really, I would say, all across the deep tech spectrum. I mean, on the one end, we've got maybe say conventional semiconductor, conventional electronics challenges. We've got big time swap, size, weight, and power challenges. So we're facing the end of Moore's law on the technology development side from the commercial foundries. And so we need innovative solutions to continue to shrink the power and size footprint while simultaneously increasing performance. This is a massive challenge that's really bigger than Lockheed, bigger than the defense space, but it's going to be absolutely necessary for the DoD, A&D in general, aerospace and defense in general, to leverage the commercial solutions that are coming online. That's an area that's particularly near and dear to me. My background is in semiconductors. I came from CMOS development world, but we have all kinds of challenges on AI algorithms. I would say next generation AI, 5G communications is a big one for us. Also trying to tap in effectively into these advanced comms markets. We have to be able to move fast. We have to be able to be agile. We have to push communication, advanced communication capabilities, compute, algorithms, coordination, all into the into the edge.
Yeah. Wow.
Dana and I would call it the battle space, but it's really getting into the edge, getting onto platforms. So these are massive challenges, and we're looking to tap to the best and brightest, the so-called spot market of technology in order to solve these problems.
Fantastic. I would take away from you two things: advanced comms, and then also you said decrease imprint while increasing performance. That is the challenge. Go smaller things, do bigger things.
Without the transistors underlying getting smaller faster, you have to be more clever, or other approaches. Yes.
Okay. Thank you very much, Ryan Hatcher. Dana Jensen from the United States Air Force.
Well, I mean, of course, to echo what Ryan said, we see the swap problem all the time. And especially as we start looking at autonomous systems, a lot of the sensors involved, LiDAR and others are power hungry, right? Which causes, if you're battery powered, decreases in your range. So anything we can do to reduce power requirements for compute is going to be a big deal. Anything that looks like an alternative to the field programmable gate array, very interesting. We'll see something about that in a few minutes. I represent the Office of Commercial and Economic Analysis at the Air Force, which is really a byproduct of, again, as Ryan said, as the government has dialed back its R&D spending, we are more at the whim of the priorities of the commercial market. Right. And so and that may not necessarily align with the things that we are, prioritizing. Right. Some of the best engineers in the world are optimizing cat videos. And, we need to deal with we need to deal with the commercial market and mine it for dual use technology, which is exactly the point behind this meeting. Right. So, we're always interested in anything that reduces power consumption in compute or sensing, anything lightweighting with respect to materials. Scalability is going to be a big deal as we look at things like advanced air mobility. What materials can we operate at scale? And then, of course, you have additive firms on here from time to time and materials people. So we're always curious about new composites, new manufacturing methods, and a lot of the new vehicles we're seeing designed may have considered manufacturability as an afterthought. And we're trying to make sure that we've got the industrial base in place, or at least the capability in place for scale to happen when the commercial market gets mature. And that's really our job, is to help people over that valley of death, that kind of TRL 5, 6, and 7 level. And we've managed, we can't write super big checks, but one thing we do is generate a demand signal. And VC comes in after a lot of the companies that we invest in because they see that demand signal from us. So, we've managed to, I think, spur about $1 billion of investment over the last year from the commercial side through VC and others, just based on our ability to, kind of triage these things and then generate demand signals that the market can see.
Yeah, dual use is the secret of the universe when it comes to finding stability as a company. We find multiple markets, one of them being obviously the public sector, what you represent in the United States Air Force, or the DoD. And but the challenge, of course, is budgets goes away from the primes and goes towards the small businesses. Is, hey, can I take something which is not necessarily appropriated? This technology is not necessarily for my defense concern, and see, well, but the core technology is there. Could it assist me in the challenge that my organization is facing today?
That's absolutely right. And one of the things that we're moving away from a procurement standpoint is this idea of everything being driven by requirements, right? That we set up a requirement and then we go, accept bids for fulfilling that requirement. Now we're starting to go out and look at tech as an answer in search of a question in some ways, and to say, hey, look, here's a capability. Why don't you guys kick the tires on it and see if there's something you can do with it? So it's kind of turning the procurement process on its head. And so far, our furtive attempts to do that have been pretty successful, and we're very encouraged.
Yeah, 100%. Wonderful. Okay, thank you, Dana. Moving on, Karthi Madasamy from MFV, sorry.
Hi guys, good to be here. This is my second showcase event. I had a lot of interesting companies to watch in the first one, so I'm happy to be back. So we're an early stage deep tech fund based in Palo Alto. We invest in Series A and pre-Series A companies, so kind of seed to Series A, if you will. We have invested in companies in quantum computing, AI hardware, humanoid robotics, EV technologies. So we look for kind of core technology companies kind of moving the needle over the next decade or so. In terms of check size, we write anywhere from $1 million to $3 million initial check, and then follow on with pro rata investments going forward. What is one or two things that we're looking for maybe in this forum? We have done investments in robotics in the warehouse, the Industry 4.0 sector. There's still more to be done. So we're looking for more collaborative robots that can coexist with humans as we kind of optimize more productivity. We are also looking at, we're also looking for like good sensors that actually can fit into that type of environment. And I think those are probably the two things that I would say biggest focus in terms of the Industry 4.0. We obviously look at computing, connectivity, startups broadly. So anything that applies connectivity and computing to an Industry 4.0 setting will be of interest. Yeah, I think that gives probably a good overview in terms of what we're looking for.
Sure.
Look for seeing the companies, and I will put my contact information on chat so that if any startup or partner want to reach out to understand more and work with us, so please feel free to do so.
Wonderful. Thank you, Karthi. Last panelist, Jacob, last but not least, of course, Jacob Hahn from Deloitte Consulting.
Yeah, it's an honor to be here. Good afternoon, everybody. I represent Deloitte, in particular, an aerial sensing solutions practice, but more broadly, all things robotics and autonomy. Most particularly interested today in learning about things related to AI, ML, and maybe specifically most edge computing. A long list of customers with an even longer list of problems, and hopefully kind of the novel solutions that y'all are coming up with are introductions that I can make between the two parties. Also, I'll piggyback on something Dana said. Customers will often come to me with a list of requirements and say, go find capabilities that meet this list of requirements. What I'd like to do is work with you all and find more pioneering capabilities and be able to come to the market and offer new ways to think about things. So thanks for allowing me to participate in today's events.
Amazing. Thank you. Thank you for that. So let's get started. Let's start off with the first presentation. I'll let you, Val, queue up the first slideshow, and we'll get started.
Eric, you're on, right? I think I see you. Perfect. You're going to be actually sharing your presentation, correct?
Yes, thank you.
Perfect. So I'm going to let you do that right now, and we can get started with Dot Incorporation. Eric, you should be able to share your screen now. We could get started.
Okay, thank you. Okay, can you see the screen?
Yeah, we see it.
Perfect.
Okay, thank you for the pitching opportunity. I'm Eric, CEO of Dot. Let me start the presentation and introduction of our company. Dot is a social impact company. We are certified B Corporation. We're based in Seoul, Washington, D.C. And we have 32 employees right now, and we have 114 patents globally. We're a really technology focused company, and we plan to do IPO in 2023. What we do is very simple. We innovate the lives of the 100 million blind people in education, jobs, and entertainment. I studied in University of Washington, and when I was in there, I became a Christian, and I saw this big Braille Bible book at the time. So, there are over 285 million visually impaired people around the world, but like they have a significant problem to access paper data and all the data on the webs right now. Many researchers in many universities try to innovate this market, such as like bringing, Braille tablets, like, you can see in here, and then Braille smartphone, but everyone failed. No one actually succeeded. And we established our company in 2015, and we have 3 products right now. One is DotPad, which is our main product that shows that, that can enable graphics and Braille both time for blind people. And the second product is Dot Braille Smartwatch, which is the first smartwatch for blind people, like an Apple Watch with the Braille Display. Our the major product called a DotPad is kind of one of a kind, which is on the left side, as you can see. This is the only solution right now until now. So you can read one line by line. You can only read text, and it's called Braille Display, and it costs about $5,000. This is actually the main main reason that I started. I met my friends in there, and in the University of Washington, and she used really expensive this Braille Display, and still is really expensive. And we are innovating this through bringing, like, maybe you guys remember the Macintosh, when the first PC based on GUI first came out, and then people can access the graphics and all the Excels and presentation, those kind of things. And we are bringing that to the 285 million blind people all over the world. So through our technology, blind people can access graphics, and they can do many productivity tools or educations. And right now we are innovating education part. So we are partnering with the US government, and we are bringing this technology to the US blind students from 2022. And we got a contract about $30 million for over 3 years. And this is how, the blind students study right now. And but we are innovating this through our technology. And we're also collaborating with Samsung to make more affordable the graphic enable tactile device for blind people. And also we're collaborating with the Microsoft team. So we are innovating this market that completely different and completely innovative solution to take over all the BRG market. And based on the US contract, we are expanding this to South Korea, China, and Japan right now. The second thing that we are doing is we are innovating the smart city infrastructures. If you see the smart city, there are many parts, but like there is inclusive smart city part, which is for giving full accessibility in every core services for disabled people and elderly people and foreigners. We utilize our technology to help more disabled people and socially disadvantaged people. We navigate this old infra, which is not helpful for special needs, which is not smart enough. So we are bringing our smart technology to innovate this market. So if you see this
an image, the first step we have taken towards guaranteeing mobility rights for all is launching Dot Kiosk.
Dot Kiosk integrates the Dot Display with a range of other accessibility technologies to create an inclusive information delivery system.
제가 가려고 하는 지하철 역사의 여러 가지 다양한 정보를 촉각 지도를 통해서 명확히 알려주고 있어서 되게 유용했다고 생각합니다.
교통사고도 키가 작으니까 많이 힘들었죠. 좀 높거나 이랬으니까. 근데 지금 이 키오스크는 딱 제 키 높이에 맞춰서 내려오니까.
So because of the time, I just cut up the video. But like this is our technology has. We bring not just for blind people, we bring the technology for hearing impaired people and physically impaired people and even elderly people and foreigners. So we had a chance to bring this technology in Busan of South Korea. Right now we are expanding this technology to the 120 station in Busan. We are installing our barrier-free kiosk with the mobility impaired navigation. So we are.
Eric, you have another couple of seconds.
Door-to-door inclusive.
It's okay. Yeah. It's okay. Finish your sentence.
Okay. Yeah. So we are expanding this as inclusive smart city infrastructures in Busan, and we are expanding tests in France, Hong Kong, and Qatar right now, and we plan to do in New York City too. Not just for the smart city, we are expanding this technology to the many government buildings. There are many needs. The government building need to renovate their infrastructures to help inclusive people, inclusivity. So we are bringing, the accessibility in every area of our industry, not just device, but to the infrastructures. Thank you very much.
You're muted.
Sorry. Thank you very much to Eric from Dot Incorporation. By the way, kudos for Eric for getting up at 3 o'clock in the morning at his time. But questions from the panelists?
I have one actually. It's okay. Hanko here. Okay. Can you hear me?
Yes, we can.
Okay. Thank you, Eric. Great product actually. I do have some knowledge in this industry. So I have a question and comment actually. The question is that I don't know too much about your product yet, but like the big giant like Microsoft got what they call the eyes first, and Amazon have like show and tell, right? And then so how is your product? I know you have some specific hardware stuff, but how you gonna approach the market in competition with whatever existing in the industry?
Where right now the startup that can bring tactile screen, which is like a monitor for us, what we see is only us right now. So this year and next year is really important for us. So right now we are working with Samsung and Microsoft, and also a very big company in the US that we cannot say, but we're collaborating with a lot of big companies right now to bring our technology specifically designed for their products. So for example, Samsung has their product and we designed for them. So basically, the blind user who are using Samsung product, they can also use our product without any problems. We are doing that right now, and also we are our first target right now is the education sector. So basically, we got the U.S. government contract, and then we are expanding this contract to the South Korea, Japan, and Europe market. So basically, this education alone is $700 million market annually. So we think this is really good opportunity for us since there are no technology. And while we are providing our hardwares, we're not just do that into the hardware part. We are bringing our the software that can translate every text data and graphic data to our screen. So this is a fundamental engine, and we are monetizing this right now. So we are expect not just hardware revenue, but also the software revenue.
Gotcha. Again, the comment is that, the Harvard has astronomy lab, and they're not just focusing on astronomy. They're focusing on visually impaired. There's some research going on. Maybe we should talk offline. Also, I'm bilingual Korean as well. Okay? I live in USA, but I have office in Seoul. Maybe we should talk offline so I can maybe help you in ways to work in these markets. Okay. So, thank you.
Wonderful. All right, that's all the time we have for Deloitte Corporations. Despite the crazy hour, Eric, just stay around for 2 more minutes and see within the chat so you can answer any questions you need to, and then good night from Seoul. Thank you very much, Dot Incorporated. Let's queue up the next presentation. Turing Micro, you're up. I think we're joined by Greg.
Yes. Hi, everybody. I'm Greg Paul, founder of Turing Micro, and I've also got my co-founder, Rob Lundstrom, on the chat. Like Albert Einstein said, we cannot solve our problems with the same thinking we use to create them. And you really got to invent something. Next slide, please. So this is our team. It's made up of ex-Western Digital CPU designers in Southern California. Also, our inventor, Bob Patiller, did one of the main original processors on the Xbox. Myself, Rob, and we have a lot of other engineers that we 1099. Next page, please. So there's a problem in the world right now in processing, and Ryan Hatcher, you mentioned a lot of bottlenecks at Lockheed that you're interested in, and Hahn Robotics. I want to show you where we can 5 to 10x the motors and make it easier to program. And Dana Jensen, we have a replacement for the FPGA. Right now, across the bottom of the screen, when you see that there are multiple solutions, multiple processors, and why is that? They have to be hybrided together because they each do some good things, but not everything fast enough or together as one. And why is that? That's because they're batch processing. The I/O gets bottlenecked into 1 or 2 main processors or a couple core processors. And this takes many, many clock cycles, a lot of hertz. So this also mismatches the processing architecture for the algorithms, and it slows everything down. Kind of like when you make an ASIC, you make it around an algorithm. In a perfect situation, you would have the right architecture for every algorithm and every input. Next slide, please. So what's our solution? It's a decentralized distributed intelligence. What's needed is a processor that can dynamically reconfigure the architecture in 1 clock cycle, a billionth of a second, without a power cycle. And then to unclog that centralized problem of a big processor, you need a core for every input, and this will end the batch processor nightmare. This is something we've solved. Like in a race car, real-time control, upshifting for faster processing, downshifting in the turns. You reconfigure the car, you change the power. We can additionally change the power and voltage in our chip on the fly. Next slide, please. So what have we invented? It's a combination. It's a compiler, which is the intelligence. It's software definable, and it's a chip we want to make. But we can build this in an FPGA to prove it out currently and even accelerate that. Across the bottom, I show you, like on the other pages, GPUs, FPGAs, ASICs, all mixed solutions. Over on the right in blue, you see the new features and why we can replace an FPGA and GPU. One's clock cycle reconfiguration. The next piece is the magic. We can process on multiple layers of virtual fabric, even with 2D manufacturing. So we can jump in one clock cycle, 1 billionth of a second, to another piece of the fabric that processes instantly anywhere. So now it auto maps, it auto timing. Anything in C, anything C compiled. So now you don't need a high definition language engineer like you need on an FPGA, and dynamically without a power cycle. This also creates a situation of auto masking the power versus time for hackers. We can change the voltage on the fly through a feedback loop. And we're cookie cutter. We can go from IoT to something better than Cerebrus wafer scale. Next slide. This is just an example. We call it a RAPSI, a reconfigurable algorithmic pipeline core. Again, jumping layer to layer, assign a core for everyone. We've got a couple patents already. We've been in stealth. It organizes the code, it compresses it, and it removes those bottlenecks. Next slide. So we were just awarded the phase 1. We're looking for phase 2, of course. But this is a comparison of some of those features I just mentioned. When you look at FPGA, GPU, ASIC CPUs, and across the board, we are the real-time supremacy king in a clock cycle. That is the only thing you give up. Everything happens in a clock cycle. It breaks the algorithms down in a clock cycle. It's completely wide and completely flat. This will help robotics, drones, autonomous AI, video streaming, supercomputing, AR, VR, across the board. And it's Turing complete, hence the name Turing Micro. So we can co-process, and we can be in an FPGA literally before we are to chip. Next page.
Hey, Greg.
Yes, sir.
Greg, you have a couple more seconds.
Okay. This is where we're headed. Sweet spots from robotics all the way to wafer scale AI. We can click between 4, 5, and 6G, replace, and we can marry any type of compute on the different layers. So this is how we do that real-time supremacy, because we can be mixing things that don't work together today. And finally, last slide, next slide. We wanted to do 2 runs in multi-project wafers and build our compiler in 18 months. Happy to have any questions.
Hey, Greg, this is Dana. I was wondering if you could elaborate. I saw on one of the slides, a couple slides back, that these things are rad hard. Is that intrinsic, or is that something that you've done as an extra step?
We can run MRAM. And MRAM, so we're talking with one of the biggest in the United States. Obviously, there's Spin in the UK, but I can't say who we're talking to over on the West Coast. But MRAM. So we can run S, D, or M, and we can be Turing complete and do more than just AI acceleration.
Okay, so it's an intrinsic character of the way you're building the thing then.
Yes, sir. And we can make it more dense than the other pieces because of this as well.
Well, that's one of the other issues we've had in the past, right? I mean, some of these rovers going to Mars are using PowerPC chips, right? Because they might be from the 90s, but at least they're not so elegant that they can't stand a little bit of disruption, from radiation.
We've simplified data movement and compute. And by doing this, we have a more efficient, effective, and then more flexible with all these different features. You're able to solve these bottlenecks.
So if I can just ask one question, I know we're short on time, but I'm interested in the roadmap here for integration in the packaging level.
The one go-to-market slide. If you can pull it up, or go ahead.
Sorry. So I'm curious if you guys are positioning yourselves for chiplet level integration, like system and package level integration. Is that something that, did I miss that?
We're at the simulation right now, which is why we went the grant route for the moment, to do industry standard simulations to show any trade-offs or comparisons for anything you like. But on the go-to-market slide, keep going. You're going the wrong way. Okay. Second to the last slide. There you go. Go to market. Go back one. Go to market. Okay. So we're going to make simulations, and then we can use anybody like Global Foundries. We're fabless, just like an ARM model license. But we can prove it today, and we can prove anything you like over the period of this. We can make actually a compiler that is a licensable compiler to accelerate FPGAs, but our chip itself will have our own architecture that we've patented and obviously give you the best of all worlds. It will integrate into anything you're doing. It's Turing complete. It can co-process or run it all itself.
Gotcha. Okay, thank you.
Wonderful. Thank you so much, Gregory Paul from Turing Micro. Moving on to our next presentation, we'll queue up the slides. Wonderful. We're joined by Elizabeth Hood, CEO and founder of Infinite Enzymes.
Hi, everybody. Thank you for joining us today. My name is Dr. Elizabeth Hood. I'm the CEO and founder of Infinite Enzymes, and we're located in Arkansas in the US. Next slide. Our vision actually is to eradicate all the forever chemicals that humans have created. So this presentation is vastly different from everything you've been hearing about with computer chips, et cetera. This is very biological. Next slide, please. Our opportunity is that Infinite Enzymes offers a solution for these forever chemicals. Through our patented biotechnology platform, we have generated a unique enzyme, a biological solution that degrades PFAS and other harmful chemicals. Next. So you ask me, what are PFAS? Well, we have several examples of these over on the right-hand side of the slide. They are polyfluoral alkanoates, which is why we call them PFAS, and they never degrade in the environment. And they're in many, many of our consumer products, such as stain-resistant coatings for clothing, carpeting, and furniture. But one that you probably are all familiar with is in nonstick cookware, which is Teflon. And we all have used Teflon in our lives. And this Teflon can chip off and get into your food. And why is that a problem? Because these PFAS create awful health risks. They have been shown to cause cancer, birth defects, and a whole lot of immune system problems, as well as interfering with hormone activities. And the firefighting foams are of particular interest to us because our first AFWorks grant, we also are a phase 1 awardee, is to try to remediate the PFAS that are in firefighting foams for the Air Force. Next slide, please. So how do we generate this unique enzyme? Well, just like a computer language offers a platform technology for creating applications in a variety of different industries, we use a plant biotechnology platform that allows us to create new enzymes that are invaluable to daily life. Next slide. Our solution includes an enzyme called MNP, or manganese peroxidase, that we are proposing to put into a filtration apparatus that will completely remove PFAS from the water that is contaminated with them and give us safely remediated groundwater and tap water. And this is really important. It's not just a filtration system, but an actual degradation system. And the manganese peroxidase that we make in our corn platform is actually less than $5 a gram, which is a really small amount. But our nearest competitors make this for $24,000 a gram. So it's a significant savings. Next slide, please. Our competitive advantage, of course, is low cost, $5 versus $24,000. We have a green technology. In other words, our platform is completely just plants, and it can also generate additional products that can be sold, such as starch and oil. There's no need for a fermentation facility. We just plant more corn. Next, please. Our potential customers are actually the manufacturers of goods. And even though I gave you the example of an individual application, such as trying to get rid of Teflon in your food, the real market potential is with the manufacturers of consumer goods, such as cookware companies, fast food packaging companies, stain and fire resistance coatings, and paint manufacturers. And most interestingly for us is the Air Force. Next slide. So we've raised $1.2 million to date, all the way from our own personal investments to a private investment and a number of different grants, as well as some sales. Next slide, please. We are asking for a Series A at $3 million for our production facility, our product construction and implementation, and as well as our deregulation for our genetically engineered corn line. And in particularly, we are looking for an MOU signee for our AFWORKS phase 2. Next slide. Our roadmap is to do these 3 things over the next 3 years. And finally, our team on the next slide. We are a family-owned business. We have the 3 hoods plus an operations consultant, our first angel investor, and our strategic officer, Karen Wilson, who is also on the call today. Thank you, and I'd be happy to answer questions.
I can ask. Thank you for the presentation. It's very interesting. Maybe can you highlight a little bit on why your competitor has such a high price point versus you? Is it something fundamentally to the technology, or is your competitor is the status quo charging up because they just feel that they can?
It's a great question, and I'm glad you asked it. The technology that, okay, so manganese peroxidase today is a fungal enzyme, and when you culture it in a fungal system, it has a very limited ability to make large quantities of it. And so our technology, and it's because it's a single cell, and these enzymes cause terrible things in single cells. So if you accumulate a lot of it, it's very hard on them. When we accumulate it in a corn system, it has no activity and we can store it inside the corn seed and build up very large amounts of it. So it causes it to be a much lower cost.
Okay.
Does that help?
Okay, so the biology is already proven that this will basically do its job. Only thing is, yes, you're able to build it in a much cheaper, scalable fashion.
Absolutely, absolutely.
Thank you.
Can I ask one quick question too? Sorry, yeah, sure. Is this are you envisioning this on the? You said you're targeting manufacturers as your
target,
the manufacturing side. So is this to be used during processing, or is this during, like, when you're done with your nonstick pan?
This is in the manufacturing of nonstick cookware, because there's a lot of Teflon waste, of course, that comes out of that. But actually, our first target market, we hope, is the Air Force, to try to remediate the firefighting foams and the, the de-icing sprays that go on to airplanes before they take off, because in the wintertime. Both of those things create a huge problem with groundwater, because it's runoff and then it runs into the groundwater, and then it starts to get in drinking water. So it's becoming a real problem.
So it's effluent. You're treating. You're in the effluent stack, or whatever, the processing. Gotcha.
Yes, and as well as catchment after use. So those are the 2 ways that we can resolve some of this problem.
Elizabeth, this is Dana. I wonder if you could speak to the regulatory risk, I guess we would say, around getting the corn product, the modified corn, approved by regulators. Where are you in that process, and do you have kind of a timeline? I know a lot of times when we deal with like FAA and others, they operate on a completely different time scale than we do. I just wonder if you could talk about those conversations.
The FDA, you mean?
Sure.
I have worked a lot with USDA and FDA, and we've had many discussions about this. The regulatory timeline is about 12 to 18 months to get completely deregulated. We currently grow it under permit, so as long as we can show containment of the crop up to 1,000 or 2,000 acres, it's not a problem as far as the regulatory agencies are concerned, but we really are looking to get it deregulated within the next 18 months. And the USDA has really lowered the barriers to getting things deregulated now. So I think it's possible.
Thank you for that.
Yes.
Wonderful. Thank you so much, Elizabeth. Dr.
Thank you.
Hood, Dr. Elizabeth Hood, Family Business, Infinite Enzymes. Thank you so much. Moving on. Next up is Argus Solutions. Should be joined by Brady Husted.
Hey.
Hey, Brady, go ahead.
All right. Well, thank you. Well, thank you, and good afternoon to everybody here. I'm Brady Husted. I'm a founder of Argus Solutions, and I'm really excited about getting a chance to talk about our technology and our company a little bit with you guys today. You can go to the next slide. So we really come down to the beginnings of what pain does it matter? We're an AR company, and what is the pain that matters with this? And so here's the reality: mistakes occur in the field when field operators don't know what they're dealing with, whether they're operations, whether they're construction, whether they're engineering. And the goal has always been to connect the field with the data in a way that they can understand it so that they can move forward and kind of be safer. This hasn't really worked out really well in the past, but now we're starting to get to the point where things are confluing together to actually solve this. And there's three real big reasons why. One, of course, is mobile devices are ubiquitous in the field anymore, whether you're, DoD or commercial or teenagers. AR has matured. We're going to kind of talk about that a little bit later because that's, of course, our core technology. And of course, systems of record are now being available to be connected and used inside the field. And when you bring these things together, you can start really solving true field operations. You could go to the next slide. So to alleviate this pain, Argus has been working in R&D on this for about 6 years, and we've basically worked in that time to help de-risk AR technology by working in various industries like government, energy, and utilities. What we're going to be delivering with this is making the information accessible to field operators through augmented reality and creating the transfer vehicle of the information so that it can go both directions through dynamic data translation. And then what this culminates in is a full situational awareness that allows a reduction of duplication of effort and allows everyone to see the same data, whether you're in the field or you're in the office, empowering the field operators to really make the best decisions they can possibly make. You could go to the next slide. So we are, it sounds like it's a theme today, and it's really exciting to see some of the technologies from some of these other founders and startups. So amazing. Anyways, we are also an AFWorks phase 1 winner. And so this does give us a few different technology possibilities. Of course, if you're Air Force, we have phase 2. Yeah, an MOU and all that stuff. If you're anything else, this does provide a sole source provider option for you if you're inside the DoD, allowing you to skip the competitive bid process and go directly to our technology. And you can go to the next slide. And I don't know if you can click the video live just so that it can be running while I talk, but I'm not sure. It no matter if it can't. Oh, lots of steps to that. Maybe not. It's all right. Picture a video in the bottom left corner. So where are we? What's the baseline? Well, we've already got a patented and award-winning technology called the Argus lens. And what this does is it dynamically converts any type of spatial data into augmented reality data and displays it accurately and efficiently in the field. This can be live, this can be cached, this can go through various ways, and it works on any of the modern mobile devices, headsets to phones, right? Basically, yeah, sorry, I lost my space there for a second. Basically, it allows you to take whatever data you have and invested in and taken for the past 10, 20 years and put it into the hands of the people who really need it. And you could move on to the next slide. So the proposal, we're going to take that base and we're extending it by adding advanced spatial location. So it's going to be a more robust model there. We're going to give remote expert support, in other words, train the trainer, and then 3D model integration. So allowing you to see everything you need to see, which is much harder than you think in a mobile world with limited processors, although maybe Turing Micro can help us with that in the future. This will give you the ability to visualize your above and underground assets much more completely, take the ability to edit that information directly into the field so you can create a better system of record, a more accurate system, and then provide, of course, peer-to-peer expert advice, allowing you to train in the field where perhaps you don't always have, you might have one expert and 20 workers. You can spread that expert across, you know, disparate spatial locations.
30 seconds. Yeah,
Okay.
30 seconds.
Perfect. So return on investment, faster navigation to areas, reduced unnecessary deployments, and basically reduce failed maintenance efforts. You can go to the next slide. In this is a very Air Force slide because we're obviously in the Air Force. Discuss funding, go to the MOU, and then really the only requirement you'd have here in Air Force is to provide feedback. And you can go to the final slide. So that's who we are. We're Argus. We, patented and award-winning and got a base B2B product in place, and we're looking to kind of expand that into a more complete and production product in the industry. Thank you so much for your time, and I guess it'd be questions.
By the way, I think I saw that Catherine put the link to the video in the chat, so anybody wants to see Argus live in action can look at the link. Questions from the panelists?
So I am curious about the computing requirements, and how is it? Is this like Bluetooth to your phone, or what is the platform that you have to that's required? Like what is it? Is it, can this run off your phone, or do you need a special, or do you provide the compute as well?
No, it can run off your phone. It can run off of pretty much any modern device. We started in 2014, so we were running on some pretty crappy phones back then. But it can be almost any modern device. And how we save some of that power is we kind of pre-cache and pre-store and pre-build some of the graphics with a cloud-based rendering engine, for lack of a better term. And so we do kind of we pre-game. Then that comes down through broadband onto your local device, and you use that. If it's cached or offline, we simply pre-do all of that. So you're sitting in your office, you turn it on, you say, I'm going to go to this area. It does all that work for you, puts the kind of the resultant effort onto your local device, and then we use that to do the visualization in the field. The other thing is we try to keep the triangle simplified for 3D rendering. That's really what kills you, is how many vertices you have. And so we try to keep that simplified. We found algorithms to help us do that so it can be faster.
So certainly the rendering, just throughput, but there's also a latency challenge. Is this Bluetooth or how, is that sufficient? Is it connected via Bluetooth, or do you have any latency? So when you shift your head, how does it track?
It's pretty much immediate. Yeah, and I understand your question now. So obviously we're using the visualization method of whatever mobile device you have, whether it's a headset or your phone. So we're showing it through the camera. So the picture your camera as a lens to look at the world. And so the latency on that, we've gotten it down to where we've got what we'd consider almost immediate anchoring. Now, if you're looking at like a 3-year-old device, there can be a little bit of a swing impact, which I think is what you're talking about. On the modern devices like the iPad with the LiDAR, we have pretty much complete rock solid connection. It doesn't move at all. It feels like it's part of the real world. So we basically been working really hard on that, because that's what makes augmented reality believable, right?
That's right. Okay, thank you.
Yeah.
Wonderful. Any last chance for questions to Brady from Argus Solutions? Thank you very much, Brady. Excellent technology. And of course, the applications is very much so dual use. Could be relevant also for Industry 4.0, I believe. Make sure you stay around and answer questions in the chat. And we're moving right on to the next presentation, 8i.
All right, how's it going, everyone? I'm Hayes Mackman. I'm the CEO of 8i. At 8i, we're a technology company that's focused on bringing real people into a digital world. Next slide, please. So our mission is we're striving to provide technology for transmitting volumetric video content between people anywhere in the world. And this includes interactive real-time communication, live broadcasts, and pre-recorded entertainment and experiences. And for those of you who don't know what volumetric video is, that's fine. I'll explain a bit more and we'll have some example as we go. Just a little bit about 8i. Over the last 24 months, we've raised about $7 million in fundraising. We did about $6.5 million of revenue in 2020, and we have approximately $2.5 million project with the U.S. Army going right now. So we're, we have a commercial traction. We've been able to finance, and we have existing projects with the U.S. Army. Next slide, please. So what's volumetric video? What's 8i do, right? Some of you may have heard of it. What is it? How does it work? So essentially what you're doing, it's a complex visual graphics problem. You're using an array of cameras. We use anywhere from 24 2K to 64K cameras. You have to sync them. You have to record the performance. You have to extract that performance from the background. You have to then reconstruct it such that it's, maintains its visual fidelity and its accuracy. And then you have to compress the data such that it can stream to a device anywhere from, for us, it's anywhere from the bit rate's either 5 megabits per second to 60 streaming, depending on the content experience. So our core value proposition, our core technologies, we have end-to-end skills across this entire spectrum, from computer vision to data compression to just simply understanding how the internet works and how you use HTTP or WebRTC to deliver content to any device, HMDs, via the web, via Unity or Unreal. So we have a broad array of skills and patents and proprietary technology across these core components that allow us to have the best technology in our segment. Next slide, please. So we've been in business for many years. We have a large array of customers, anywhere from SoftBank in Japan to the U.S. Army, obviously domestically, CSIRO in Australia, Pike Energy Company, industrial in the United States, others throughout Asia and United States and North America. So some of the most interesting things we're doing right now, a lot of it has to do on the enterprise side with training and simulation and moving into collaboration and communication. So for example, the US military, we're doing a TCCC, so a tactical combat casualty care simulation, specifically around tourniquet training. So the problem they were having was, look, we were making these trainings, but they're not real people in them. So yeah, people like them, but it's a gloppy, weird looking object. Instead, you have authentic human performance. We actually have soldiers or trainers from Camp Pendleton who perform it, and then they're injected in the simulation to describe and discuss and train. And then we also go in other things. We're working on remote medical diagnostics. So the patient is in our capture area, a doctor is remote in a VR headset or an AR glasses and able to do an examination in full volumetric 3D video. On the commercial side, there's influencer content, sports, all that stuff's happening in the mobile AR space, a lot like the SoftBanks and the WWEs and others of the world. That's what they focus on. So there's a lot of use cases for real people and digitally immersive experiences, whether it be VR, AR, or mobile AR. And so our technology supports all those things, whether it's a video technology that supports any of those sectors. So move on to the next slide, please. When you think about how, what's a product look like in this space? So we really have 3 products. The 1.0 being your typical, this is probably the right solution for most cases. There's a 2.0, which is if you want to go wild and really invest. And there's a 3.0, which is the smaller, scrappier version. So what you're talking about is it's really defined by the amount of cameras. The more cameras you have, the more visual accuracy you're able to get via viewpoints. All of our software comes with a web-based CMS so that you can just organize and distribute your assets. We have an advanced adaptive streaming player architecture that works across varying network scenarios. All that stuff's also been tested in market. We're enterprise grade. We have large customers around the world. We have comprehensive playback solutions, so you can do web integration with A-Frame, WebXR, 8th Wall, Unity, and Unreal. So complete control over how you do it. In addition, as I said, we have both video on demand, live broadcast, and real-time content. So anywhere from process it, save it, to process it in 100 milliseconds and stream it for interactivity.
Another 30 seconds.
Yep, that's cool. We're almost done. Great. So that's a product line. Next slide. So rather than me try to play the videos here and it gets all goofy, if these links will literally allow you to play volumetric video on whatever. You can see the instructions right here. Now it's pre-recorded, it's not live. So if you want a demonstration of interactive communication or live broadcast, certainly welcome to schedule one with us afterwards. But you know, if you're interested in what volumetric video is, you can click, depending on your device, either one of these links will work. It streams to your device. It has examples of, you know, we have actually a little bit of our military, the TCCC training in there, as well as me talking for 4.5 minutes, if you're interested in stuff like that, as well as some other things. So if you want to know about volumetric video, just click on those links whenever you want. And we'll wrap it up right there.
Hayes, you put those links in the chat as well, right?
Destiny, I believe
Yeah,
she did.
I just did. Yeah.
Okay, fantastic. Yep.
Awesome. Perfect.
Questions from our panelists?
Good.
Nothing like a little awkward science. Hayes, I got a question for you.
Yeah.
Application cross DoD. How would you go about that? I know you have an Army application. How would it relate to another sub-agency?
Yeah, so I would say, like, for example, we just pitched on we just submitted a proposal for battle space scenarios in the Signal Corps, right? So you have essentially different training scenarios where they want to have real soldiers or real participants, both on a pre-recorded or an interactive basis where you have people streaming at the same time. So it really, that's basically any training scenario that requires real human performance in it or interaction could be leveraged to that. We're also thinking out in the future as like mobile communication units so that you could deploy them in the field. You could hook them up to a low orbit satellite network or a direct network. It could be allowed for whether it's battlefield commands, it could be a phone home service for the soldiers so that they can have that kind of experience with their home. It could be for remote medical, anything you want, especially if you think about like the HoloLens project they're doing. So our stuff already works on part of what we're doing now is on HoloLens as it is. So any sort of communication or recorded or even just it all goes through the HoloLens or whatever the future of that may be. So there's a lot of different ways. Basically, it touches pretty much anything where humans are involved in video.
Perfect. Thank you very much.
Got a quick question here. Great presentation and technology. Is your technology bound by any specific, regulatory process like Defense Technology Security Administration's policy? So you cannot work with any foreign entities?
No, I mean we have no restrictions on that. It's not top level secret. So we work with we have products with countries all over the world.
Okay. All right. Thank you. Maybe we should talk offline later.
Yep, sure. Yeah, no problem. Yeah, if, any other questions? It's kind of we had some complex questions on graphics distribution earlier in the previous one, so I think that covered it.
Well, wonderful. Thank you so much, Hayes. From 8i, any questions afterwards can be asked and put in the chat. Moving on, this actually concludes our open tech session, and we're moving straight into our next session, which is the Smart Factory. So as we are in the Smart Factory, or the brain as we like to call it, we're joined by our panelists. So I'm going to let the panelists introduce themselves, but we're going to be joined, I'll just give the names, Ted Machuba, Karthi Madasmi staying on with us is Jacob Hahn, joined by Todd Stavish from SRI International, Rose Chen from Wesco Distribution. Joining us from Army Futures Command is Desiree Grogan. For Worldwide Tech Services is Mark Bodner. From Siemens Digital Industry Software, Charles Grover, and from the city of New York, Jen Nabarakawa. So we're going to get started right in with the first presentation just momentarily. I just want to give an opportunity for all the panelists to just say hi real quickly. Those who are carrying on from the previous panel, we've already heard from them, but just also if you could just state your name and your primary tech interest. Let's go around the horn. We'll start with Ted.
So yeah, this is Ted Machuba. I am at Fort Benning, Georgia, and we are interested in pulling capabilities in robotics, autonomy, and artificial intelligence down to the soldier level, but definitely the small unit level. And when we say small unit, it's It's the 40 soldier platoon and below. Over.
Wonderful. Wonderful. By the way, I just did my whole mental slip. I forgot to say proper thank you to all of our panelists that joined us from both industry, corporations, and from investors, and as well as from federal government and city government. Thank you so much for joining us, and for all the companies for presenting. So next up, Destry from the Army's Future Command.
Hello, my name is Destry Grogan. So I work as the Director of Integration for the synthetic training environment for the cross-functional team down here in Orlando. So underneath Army Futures Command, we do a lot of the modernization and the innovation within the Army.
Thank you, Destry. Sure. How about Carthy? Do you mind getting on camera again and introducing yourself real briefly?
Yeah, sure thing. Hey guys, it's Karthi from MFE Partners. We're an early stage deep tech fund here in Palo Alto. We invest across a variety of technologies in deep tech. We've done investments in quantum computing, AI hardware, humanoid robotics, EV technologies, computer vision software, data management software. We write checks anywhere from $1 million to $3 million and kind of focus between anywhere from C to Series A. Yeah, look forward to the companies and presenting today and interacting with other panelists. Thank you.
Thank you. Jacob from Deloitte.
Yeah, good afternoon, everybody. Jacob Hahn with Deloitte. I'm the leader of our commercial UAS program, more specifically, but even broader, all things autonomy and robotics in the context of, I think, today's topic, smart factories. Really interested in sensing solutions and the data capabilities that enable scheduled maintenance in the context of factories.
Fantastic. Thank you very much. Todd Stavish from SRI International.
Hi, Todd Stavish, SRI Ventures Managing Director. We're the venture arm of SRI International, who does a lot of research and development for government agencies, and as well as like programs like DARPA. We also do a lot of research and development for large multinational corporations. I run the venture arm, and so we take a lot of the tech that we develop for these customers and spin them out into ventures. So I'm really interested to participate in the panel today.
Thank you, Todd. Rose Chen from Wesco.
Hi, everyone. Pleasure to meet you all. Rose Chen from Wesco International. We are a global supply chain distributor and logistics company, publicly listed, and currently looking for solutions that can really help us to digitally transform our company internally, but at the same time also going to market with customers. And we're also a strategic investor in this space. So anything that is related to supply chain, logistics, distribution, we would be very interested.
Wonderful. Mark Bodner, Worldwide Tech Services.
I think actually Mark might not be here quite yet.
Okay. Well, moving on, Charles Hofer from Siemens.
Yeah, I was looking for him also. I think there's a couple people who'll be joining us in a couple minutes because we were running a few minutes early. But they'll be here. They'll be here in a few minutes. Same goes for Jen, I think.
I think Jen was on the line. I saw Jen on the line a little earlier. Jen, are you there? Okay. So if not, we'll jump right into the companies. First up, Yuval, who do we have first?
We got Deep North presenting first. Rohan, are you here?
Sure. Yeah, I'm here. Hi. Good afternoon, everyone. This is Rohan from Deep North.
Go ahead, Rohan. The stage is yours. Feel free to start whenever you're comfortable.
All right, great. Good afternoon, everyone. Thank you for the opportunity to present. Quick introduction. My name is Rohan Sanil. I'm the co-founder CEO of Deep North, based here in Foster City, San Francisco Bay Area. A quick introduction on Deep North. If you want to go to the next slide. So Deep North, based here in Silicon Valley, Foster City, our entire mission is to digitize the physical world for our customers that have a physical footprint. And with our computer vision and AI platform. And what we do is we tap into the existing infrastructure, which is the camera infrastructure, and provide insights and decision-making insights for our customers. So we look at the physical world as if it is a web page. So we convert, whether it's a shopping center, retail, commercial real estate, warehouse, or an airport, into a digital format and provide the capability of presenting that as if it was a web page. So now customers can look at one store or 1,000 stores or hundreds of warehouses as if it was a website and understand everything that's happening in there. And within that, we are very focused on object detection, object tracking, and analysis of that object. And it's primarily on human behavior in the physical world. So when we talk, the company is 5 years old right now. We are transforming the brick and mortar enterprises. And if you look at all our customers that we've gone live with, everyone is using technologies like RFID, sensors, beacons, Wi-Fi, cell phones, data, and even human clickers. And the consistent message that we've got for the last 4 or 5 years is that data is not accurate. So we cannot make good decisions with that data. It's all derived metrics to reach that level of accuracy. So DeepNot's computer vision platform provides that highest level of accuracy of understanding the human behavior in the physical world and provide that level of insights that each and every stakeholder needs. Next slide. So our core technology and competitive advantage is our video analytics platform that leverages on current camera infrastructure and derive results in real time. So literally, whether it is a 1.4 million square feet shopping center or million square feet warehouse or an airport like Atlanta Hartsfield Airport, we can provide information through existing video cameras in real time. We tap into any cameras, whether it is a $50 camera or a $1,000 camera. All we need is 720p or 1080p feeds. We look at those feeds and we do all the processing on premise. It's 100% processed on premise, and by doing that, we are GDPR, CCPA, PII compliant. We do not need to store a single video after we process it. Only metadata goes to the cloud, and again on the cloud, it could be any choice of cloud that the customer wants, whether it's AWS, Azure, or GCP. And we have a full-fledged visualization layer as well as a mobile app. So if you look at the entire pipeline, we have now taken a warehouse or a commercial real estate or an airport and transformed it into a web page. You can literally manage your entire properties from your mobile phone. We are a data processor. It's your asset. We are data processor, data analyzer, and create insights for you. And we call ourselves as the ubiquitous platform that can reside or tap into any cameras. The on-premise compute can be any hardware vendor, whether it's Dell, HP, IBM, Lenovo. The cloud could be your cloud, our cloud, doesn't matter. And the analysis could still be on our platform, but we have a full-fledged API solution that can feed into our customers' platform. So that's how we deploy our solutions. It's fast. So for example, we could-
You have another 30 seconds.
All right, next slide. So the use cases are understanding people flow, occupancy, space, management, understanding how vehicles behave in the environment, and many other applications that our customers want. We have detected, tracked, and traced more than 130 million human objects in the physical world in real live environments, and our customers are companies like Home Depot, Delta Airlines, both are investors in Deep North. And we are now working with large enterprises like Wayfair and Lucid, hopefully to help in their warehouses and manufacturing. We recently won the contract from DHS TSA to build the seamless check-in for the TSA check-in process. We are live at Delta Airlines Hartsfield Airport, where we analyze and predict what the queue lengths and times and the service times could look like, and send out real-time alerts for associates so that they can go out and help customers. And we have many other examples and use cases with our customers, both here in the US as well as Europe. And now we are also expanding in the GCC markets. Next slide. And if you look at it, you know, a massive warehouse over here can be very easily within a weekend converted into a digital warehouse. And it can be AI powered with existing video cameras. You do not need anything other than your existing infrastructure, whether it is understanding dwell, understanding loading times, understanding the safety, the movement of people, movement of forklifts and various other equipment within the warehouse. Everything is analyzed. Insights are derived from that, and we also give recommendations, predictive and prescriptive analytics, and we track those and make sure that the predictive and prescriptive analytics are generating ROI for the customers. Next slide.
I think we have to wrap it up here at this point. Maybe you can skip right to the end and show what your ask is.
Sure, sure. Go to the next slide. Next slide. This is our roadmap for our products. Next slide. So we've won our first government project. We also have our second government project with the Air Force, which we've just started working with them. And the ask over here is, we've been very successful in the enterprise market, and we wanted to connect with the government entities and make sure we are with the right teams, presenting to the right folks within the government world. So we've this is our first project with the federal government, and we want to now start working with the right team members within the government entity and present Deep North solution, present our Kickstarter programs, and hopefully we could scale up in this vertical too.
Thank you very much. Let's open up the floor for questions from our panelists.
Yeah, so this is Ted Machuba from the Army at Fort Benning. So I was really interested with what you're showing in terms of capability within a factory or an airport. So do you see your process as being able to work in a very austere environment with sensors on robotic systems and communications that may not necessarily be as pristine as you'd have inside of a building or something like that? Could you move it out to that tactical edge? Over.
Sure. So we are also doing with Delta below the wing analysis, which is on the tarmac and the apron analytics. So we analyze as soon as an aircraft comes in, by the time it comes in and by the time it leaves or takes off, what all happens within there, all the analysis of each and every equipment that moves. Does it follow SOPs, the human behavior? Do they follow the standard operating procedures? So we're working on very critical applications for Delta, which is below the wing applications. And I don't know if that is something close to what you would be looking at, but we'll be glad to share some of those use cases that we are measuring in terms of performance and operation efficiencies for below the wing applications.
Well, I would say that if you can imagine that that's taking place on a grass airfield someplace, you know, with mud and dirt and things like that. And then one of the ways that we've been working with industry lately is through other transactional agreements. Have you had any experience with OTAs? Because
no.
Go ahead.
No, we've not had that experience yet.
Okay.
So our first experience is with the DHS TSA.
So I will tell you that the way that really works is you answer a request for white paper, for prototype proposal, submit something, and then you work with a consortium that is the industry facing part of that. So that might be something that you might be interested in looking into. And there are consortia that do hundreds of millions of dollars worth of business transferring government money to industry to mature technologies for military uses. Over.
Absolutely. So we do have, you know, our applications that are true edge, that are right at the camera level on a box that can, with 5G, can provide real-time insights. So we've got a couple of applications that are deployed with customers. So definitely we'll look at that, what you just mentioned, and you know, try to approach it from that angle.
Wonderful. Any last question for Deep North? Okay, thank you very much. Great presentation, better technology. Thanks, Ron. And let's get started and on to our next presentation.
Hi, my name is Jim Wickenheiser. I'm with Silicon Core Technology. We've been a display manufacturer for several years, and we want to take you through some of the stuff that we've done, as well as go into some future stuff that I think you guys will all find very, very interesting. Next slide. There's a major problem out there. There's a need for high efficiency, high brightness, rugged displays for use in vehicles, training, simulation, as well as command and control. This can also extend into logistics type environments where there might be some ruggedization that's necessary for people might be bumping into things. So we can handle that type of situation as well. Next slide. So our vision is to replace most modern display technology, OLED, LCD projection. It can all be replaced with direct view LED, which is the type of displays that we make. They're flexible. You can put them into any environment, any size, any shape, any resolution. They're much brighter, 10 times brighter than LCD, 20 to 50% brighter than other direct view LEDs from our competitors. And they also have the best image quality of any display out there. One of the beautiful things about them also is they're also the most efficient. LED is the most efficient type of light source, and we are the most efficient manufacturer of these type of displays. We've got some patents around that I'll discuss in a minute. And because of our efficiency, they're also quiet, so we don't require any fans to run. Next slide. So when you're talking about simulation training and control rooms, a lot of times they're using projectors in those environments. And so we're looking to directly replace those. Also, we've developed a passive 3D technology that could potentially go into a drone control situation. And we've also developed a walkable floor. So some of the ruggedization that we've started to develop actually makes it so that you can put up some sort of logistics type information on the floor and actually walk the theater and see where problems are and see where you might be able to bring solutions. In terms of vehicles, this is a heavy R&D area for us because we need to miniaturize, really reduce the size of these type of displays. So unlike LCDs that kind of are natively small and they have to struggle to get larger, LED goes the other way. It is natively very large, and the challenge is to make those a smaller, more efficient display. And so we have already developed some of the technology to do that, but there's still a roadmap ahead.
Sorry about that.
And,
Make sure everyone's muted.
And so there's also some ruggedization and environmental, extreme environmental enclosures that need to be developed. Next slide. So enabling technology, I alluded to this earlier. We actually also make the ICs that drive the LED walls. So the driver chips themselves, we are manufacturers of. And so in those drivers, we have a technology called common cathode, LLP, and ZAC technology. Those technologies both help make them more efficient as well as increase the image quality. So the ZAC is the image quality, common cathode and LLP really help drive efficiency. And that's paired with our LISA technology, which is an encapsulation technology that really helps ruggedize these type of displays. It's way more robust than, say, your cell phone. Like if you were to drop this type of display, there's no issue with cracking or chipping or anything like that. Next slide. So this is the basic team. Eric Lee is our founder and CEO. He's also on the call today. He's got over 25 years experience in the semiconductor industry, over 25 patents to his name. My name's Jim, and I've been in the AV industry for over 20 years in various roles between hardware and management, all the way up to being global head of business operations. And Nikos, who is not on the call, has also got about 25 years experience in the semiconductor field. So next slide. So basically we've got, that team is set in place this business model for growth, right? So we want to develop and sell high performance displays for the most demanding applications. We're also looking to license our IP as well as sell our ICs to other trusted partners. You can read that as Asian, but not Chinese. And we're also looking to become ODM manufacturers for a few global brands. And we're hoping to bring some manufacturing back home as well. So we'd like to build a R&D and manufacturing facility here in the US. And so we're hoping
Another 30 seconds.
Okay, next slide. So we're already a company with global traction. So we're already worldwide with offices and R&D teams. The revenue ramp that you see on the right, the one that's highlighted, that's for this year. That's based on real projections that we've signed an ODM agreement with a very large major Japanese electronics manufacturer. So that's not a speculative number. That's actually, that's part of our funnel. And the out years, that's based on our projections as well as our partners' projections. So again, these are founded in reality. So next slide. Yeah, so we're looking for 50 million in investment, 15 for IC development, 15 for process for ruggedization, and then 15 for the factory, and then about 5 for licensing and legal. Now, obviously, that can be a staged investment. It doesn't necessarily have to come all at once, but to ultimately realize all these goals, that's about what it's going to take. And so hit the next slide. All right, so the next few slides are some examples of installations and partners. So you can actually cycle through these fairly quickly. Just keep hitting next. So that's the Wynn Casino, that's Harvard Business School. We've got retail deployments, keep going. And then, yeah, these are some folks that we've already worked with in the past. And then the very final slide, when we get down there, you might recognize some of these names. So, all right, so this last one is actually very recent, within the past year. It's a Army simulator that we did at Tufts University, and it's a curved display that also has a mobile platform. That's it. Thank you very much.
Wonderful. Thank you so much, Jim, from Silicon Core. Panelists, you don't need to be shy. You can just pipe in with questions when you have.
Yeah, I have a question. Hi, this is Karthi. We looked at the space several times over the last 2 decades. It's just that it was never able to get the economics to work compared to some of the Asian manufacturers
Sure.
for displays. So outside of some requirement that it needs to be built in the US, how do you compete with how do you make the economics work against
Yeah.
the Asian competitors?
So that's a good question. The main thrust of the U.S. factory, in all candor, would be more towards secret military and secret government projects to really make sure that the whole supply chain is established domestically and to a lesser extent with allies. So we do have manufacturing in Taiwan as well. We also, it is tough, right? Part of the way that we're able to make the economics work is that we have several patents that truly separate us from our competition. So we are a high-end display manufacturer, and we have features that other people just literally don't have. So if you need a display that is quiet and cool in this space, because that's one of the really big difficulties, is direct view LED can get hot. And so you end up having to put in additional air conditioning and other mechanisms and fans to try and keep these displays cool. Ours runs so efficient that you don't need any of that. And in fact, our temperatures are, some of them actually are closer to ambient temperature.
Okay.
So also the ruggedization. We're best in class in ruggedization as well.
Okay, thank you.
Yeah.
When it comes to just like to cell phones and devices, so what's that going to do to the cost of the device itself? What's the installation of your product going to do to the cost of the device itself?
Yeah. So initially, candidly, we don't know what the final price is going to be, but we actually ultimately think we can be competitive with current tech. It's going to take an investment. There's definitely some breakthroughs that need to happen to truly have a directly competitive product. And so that's not a 6-month thing, right? And so that's part of why we're discussing this with folks like you, is that this is, not 6 months out, it's a year or two out, right? And so the biggest challenge on LED, as I mentioned, is actually getting it to those smaller sizes. And so there's new manufacturing techniques that need to be invented. We've already had some breakthroughs on that front, but they're not ready for mass production just yet. So part of this effort would be figuring out how to scale that. But yeah, that's one of the huge challenges here, is to make sure that the price point's right, as well as manufacturing's right.
Awesome. If there are no other questions, thank you very much, Jim from Silicon Core. We'll move right on to our next presenter. We have Greenwich HR, also known as Market Advantage, up next.
Kerry, you here?
Yep, I sure am. Can you hear me okay?
Absolutely.
Great. Thank you very much for the opportunity to talk to you today. I'm here in Minneapolis, where the weather has turned quite beautiful. I'm the CEO and the founder of Market Advantage. In the commercial space, we go to market as Greenwich.HR. We're a bit different than the other firms you've heard from today, in that we're a provider of labor market intelligence. We provide data as a service using a data platform that's the largest and fastest growing source of real-time labor market intelligence in the world. So information about jobs, hiring, pay, skills, careers, what the talent market looks like, who's winning in the talent market, as well as a variety of business intelligence capabilities that are based on how companies communicate and signal what they're doing through their hiring patterns and behaviors. Founded the company in 2015. We went live with our platform in 2016 and went cash positive in early 2017. We are entirely client funded at this point. We have clients, and I'll show you some of these in a minute, in the commercial and the academic space, and we are very interested in extending the value that we can provide in the defense and government more generally spaces. Next slide, please. There are a lot of applications for real-time labor market intelligence. I'm going to focus on what can be done in the defense space on this discussion. If we want to talk about some of the other applications, let me know. I would love to talk with you offline in other areas. Every one of the branches is executing a significantly enhanced talent strategy to deal with the realities of competition for talent and talent requirements in the 21st century. And with those talent strategies comes a need for much greater visibility to what's happening in the market for talent and skills overall, not just within the space of the people within any branch. General Kelly in the Air Force, I think, put it really well. Talent management system has to understand what does the talent market look like and how do we become an employer of choice. So that's right. If you want to answer questions like, how can we make sure that the skills that are being developed by our reservists in their civilian jobs are being put to best use in their roles in the military? You have to understand what those skills look like. If we want to understand how to ensure that we can keep our service members, we have to understand things like retention bonuses and so forth, and how those are competitive with what other options exist outside of the military. And traditional data sources to try and answer those questions are woefully inadequate. If you're talking about census data that's looking at talent supply, company footprints and so forth, that data is years out of date. If you're looking at pay data that's available is based on pay decisions that are often 2 to 3 years old. Even hiring data put out by the government every month is significantly inaccurate and not replicable. So, and really it's at too high a level to be actionable. So we founded Greenwich.HR to take advantage of next generation technology to really capture what's happening in the labor market in real time, at large scale, and with high precision. Next slide, please. Okay, so the data platform that we offer is not like any other source of information that's available when it comes to jobs and skills and pay and so forth. To put some of these numbers on the page in perspective, we track what's happening with 70% of all the new jobs that are created in the US. That translates to just under 200,000 new jobs that we capture attributes on every single day. On any given day, we're monitoring the hiring behaviors of over 1 million companies. We also have publicly facing individual career profiles for over 450 million individuals worldwide. About 150 million of those are in the US. So in addition to having world-class data collection capabilities, really the underpinning for the whole data platform is the ability to integrate data that spans millions of sources and put it in one common framework, one set of taxonomies, one data architecture. So anyone interested in any specific topic or question can see the entire labor market through one common lens. That's a patented technology that we introduced when we launched the platform, and it really creates a powerful way to see what's happening in both the big picture and at the small in the smallest picture.
Another 30 seconds.
Great. Can we go to the next slide, please? Here's a couple of the clients that we've served in the commercial and the academic spaces. Our clients find the data platform extraordinarily robust. It's deliberately set up as a cross-purpose platform, so there are a broad set of use cases. If you go to the next slide, please. They tend to fall into two areas. One is around signal intelligence and the other is market analysis. Most of the military opportunity that we're talking about here is around the market analysis. Who's hiring what jobs, what they're paying, what skills they're looking for, and so forth. Just in that space, the business intelligence component of the market, the commercial market right now, is valued at over $240 billion. Can we go to the next slide, please? All right, so as a data as a service platform, again, looking at more flexible and powerful ability to bring talent to bear on the needs of the military and to take the best advantage of skills that are developed outside of the military and developed in the military that then move into the civilian space. You need a platform that is ideally suited with scale, transparency, integration, has low latency, and is market proven. And that's what we bring to the table. As I mentioned, we're looking for military and government partners to be able to apply the data platform to solve the needs of the talent strategies and really win the war for talent in the 21st century. And with that, I'll leave it open to questions.
Wonderful. Wide open for the panel. Any questions you have for Kerry Sparrow?
Yeah, so this is Ted Machuba, and I will tell you, I've been a civil servant now for 20 years. I have worked in federal service now for 40, and I will tell you that in my view, you have an uphill battle to try to bring talent management into the Army, into government. I applaud the idea. I will tell you, it will be really, really hard. And so I don't know what else to tell you. There are no silver bullets. This is something that we have to do, and there's just so much cultural baggage and friction that you have to work through to really bring talent management into what we do within the government. So sorry.
No, it's by the way, that's not unusual in the commercial sector as well. There are a lot of really ingrained practices and beliefs that more and more companies are recognizing are not adequate, and I think the leadership in all the branches recognizes are not adequate. Our approach is pretty practical. We make it easy to bring our data into specific environments. We encourage our clients to bring it in a way that users are already working. So it's an augmentation rather than a replacement for what they're doing, and to manage the change of having better visibility, starting where people are. Because you're right, trying to dramatically change an organization as big as the Army or the Navy or the Air Force is a challenge outright. But when everyone believes they understand how to manage talent, it becomes even a bigger challenge.
Can you talk a little broadly about your pricing structure, let's say for corporates?
Sure, we target very savvy analytics teams and technology developers, and our pricing is either on a subscription basis or on a revenue share basis. So pricing ranges can range on a subscription basis for commercial and academic clients from a few $1,000s a month all the way up to mid 6 figures a year. Revenue share, it's a different pricing scheme based on the role the data plays in the product that's being brought to market. Did that answer your question okay?
By the way, Mark, first of all, great presentation, Kerry. If there are more questions, we'll get ready for the next one. So it's Kerry Sparrow from Greenwich HR or Market Advantage. Mark, give you a chance to introduce yourself. I think you missed out on the introduction to the beginning.
Are you talking to me?
Yes, Mark Bodner.
Okay, yes, I guess I was a few minutes late. So I run biz dev for a company called WWTS, or a outsourced technology provider. We're in about 187 countries. Before this, I did a lot of different things. I was the CEO of 2 startups, not the founder, so I was brought in by the founders. I spent about 7 years doing sort of investment banking and consulting for startups and for investors in this startup landscape based in Israel. I then ran a mobile app, an app and software development firm based in Jerusalem, and now back in New York, and I'm running biz dev for Worldwide Tech Services.
Thank you very much. Once again, thank you to Greenwich HR, also known as Market Advantage. Moving on to our next company. We're joined by Franz Incorporated, presented by Dr. Sheng-Chang Wu. The floor is yours.
Can you hear me now?
Now we can.
Okay. Yeah, you mute me. I forgot to unmute it. Anyway, I'm Sheng-Chang Wu from France Inc. Today I'm going to share with you some of our experience in smart manufacturing. Smart manufacturing is Industry 4.0. Next slide. There are 3 key components for Industry 4.0. The first one is all these sensor, Internet of Things everywhere. It measures the machinery and send out the copious data continuously. And you need some kind of machine learning technique, algorithm to make sense of all this data. So is the machine running correctly? Is the machine running into a problem? When the machine running into a problem, you need the explicit and tacit knowledge to fix those problems. Next slide. We did one of these kind of project with Kyocera, a $14 billion company in Kyoto, Japan. They dominate the industry ceramic packaging business for IC chips, something like 70% or maybe even higher. Next slide, please. The industry ceramic manufacturing is a very complex process. For example, in this continuous furnace, there's a 20 baking chamber. Each chamber will have a different kind of chemical, air, different kind of temperature. And there's 90 sensors continuously measure the temperature, the humidity, the air pressure, the airflow, all this information sent it out. Next slide. Unfortunately, when they see a problem, like a temperature hiccup like here, it's too late. The whole batch could have a problem. So the question is, can the machine learning help make sense of all this data? They got copious of data to prevent furnace breakdown before it actually happens. So you can, take some action. Next slide. So there's many different machine learning algorithms. Which one should we use? Is deep learning the best choice? That's a very popular hot one right now. Is this the best choice? Next slide. The answer is no. Deep learning is good for many things, facial recognition, voice recognition, but for this kind of industry sensor, it's not a good choice. The best choice is ISHM, stands for Inductive System Health Monitoring algorithm. It will give you a much better result to deal with this massive sensor data. Next slide. So we use ISHM to build a model, a learning model, and we'll plug in the furnace sensor data into it. In the case I just showed you that the problem happened, more than halfway through. But at the very beginning, you already can see drifting. The data, the sensor send out data that it's not within the range. And so that will tell you something bad is going to happen. And so you can take some action or address the problem before it actually happens. Next slide. So what do you do when the ML model detect a problem? Most of this kind of knowledge is either in engineer's head or on menu or in other nodes. And this kind of knowledge is not computable. And the obvious example, Kyocera case, that when senior engineer is on site in one of those remote factory, the problem is much less. When they left, problem happen more often because all this knowledge is not computable. It's not shareable. Next slide. Next. And here is an example of the knowledge of one furnace. There's a 90 sensor, and so turn to 90 rows, a gigantic spreadsheet. And this is just partial display. It's very difficult to use by other people or for computer to make sense of it. Next slide. Next slide. So we need to turn the knowledge, all this knowledge, into a computable knowledge graph. You jump ahead. Please go back one slide. Hello, you are? Yeah. This is an example of two sensors. And it shows all the, when the sensor exceeds upper bound or lower bound, what's likely the problem, and for each different cause, what's the solution, how to solve this problem. And it's just for two sensors. And there's 90 sensors in the continuous furnace. And so it's a complex knowledge graph. But now the knowledge, it's computable. So computer can help Next slide. And so you put this knowledge in the cloud, you can access anywhere. Kyocera has factory everywhere in Asia. They can access this information and allow the computer to help solve the problem. Next slide. So this is the vision. The vision of Kyocera basically is that you will have this machine learning module plug into the furnace sensor or this PLC sensor. And please click. Sorry, this is animation. Could you click? Yeah.
There you go.
Just go ahead. Anyway, enough. Stop. So when the furnace, when the machine learning module detect a problem, it will inform the engineer. The engineer will go to a knowledge base and to find out what is likely the cause and what's the solution to the problem. And also throughout this process, the machine learning module, whenever they detect a problem, they will record the problem within the knowledge base, and this knowledge base will be able to share with all the other furnaces globally. And when you accumulate enough historical information, then you can use machine learning again to identify what brand of furnace, what kind of furnace, batch furnace, continuous, different kind of continuous furnace, what kind of furnace is good for what kind of process. And this can be very useful information down the road. Next slide. So throughout this project, we find the biggest challenge is how to transcribe the operating knowledge in menus or spreadsheet into a knowledge graph. I mean, right now we do it in a manual process, and manual process is not scalable. And we like to automate this whole process. And also
Another 30 seconds.
This is the last slide. And we also want to incorporate the graph neural network to estimate the breakdown interval. Traditional machine learning may not be good at dealing with this graph type of event. And of course, we want to integrate the machine learning module with the knowledge automation, the knowledge base directly. And so the whole process will be connected. Ultimately, you want the knowledge base to send out a signal, send out instruction to the machine and actually make the adjustment automatically. So we're looking for some funding from the government, to do these kind of things. Thank you very much. That's my last slide. Any question?
Hi, this is Rose from Wesco International, and we're looking at the areas in knowledge. How are you compared to some of the competitors in the space?
I don't know much about the competitor space, but I do know that when we compete for the Kyocera project, Kyocera is such a famous company in Japan. And so many people, IBM Japan, Toshiba, everybody tried to get business with Kyocera. We beat them out because they all use deep learning algorithm. And we have a special algorithm, as you mentioned, is this ISHM. And we actually make the prediction because they give us the test data set, and we actually make the prediction. And other people, many people probably will have the machine learning algorithm to even if they have ISHM, they can make the prediction. Not a lot of people have an ability to encapsulate the knowledge, and so that can do this knowledge automation. Many people look at the artificial intelligence, they look at the algorithm. How do you do facial recognition? But another big part of artificial intelligence is how to use the knowledge to automate the process. And that's one area that I think we have a unique capability. We have uniqueness. Do I answer your question? Any more questions?
I'm going to just throw in one question there. Can you speak to a little bit of your traction so far as a company, whether grants or investments or additional customers in addition to Kyocera?
Our company main product is it's an AI development platform and also a knowledge database. It's a horizontal product. And Kyocera is one of the vertical applications that we work with as a consulting service. We work with Kyocera using our tool set. And we have been around for more than 30 years. For a while in the 80s or 90s, every AI developer used our platform to develop their application. So we've been around, we're totally self-funded. And we have been funded by DARPA a couple of times, more than 10 years ago, and basically developed to enhance our AI development platform. So we're looking for any government funding or anybody that who interested in this space, and we can partner together.
Thank you very much. So that was Dr. Sheng-Sheng Wu from Friends Incorporated. Moving on, thank you very much for your presentation. Moving on to our last company presenting in the Smart Factory or the Brain category. We're joined by Charles White, CTO of Phonetics.
Aloha. Actually, I kid. I'm actually meeting with customers in Hawaii this week, so I am calling you from a beautiful view in Honolulu. So good morning, good evening, and no matter where we are, I want to say thank you and getting the opportunity to speak to the team today. And I want to start with as we go through what Phonetics is. Phonetics builds a platform that's a cryptographic operations platform and key management service. And it's designed to address machine and human identity at unprecedented scale. And so what we're going to talk about today is that the application of the Vault Core platform in a smart factory instance for machine identity and access management. Next slide. So when you look at what Vault Core does and the way that we package our products, you can see that they're basically designed for things like tactical edge, data center infrastructure, and ultimately IoT 5G edge, which really we're going to focus on that last one today, because that's really where we're speaking about things that go. And then you look at the model and how we would do that, or actually are doing it, it's probably a better way to say it, is that you see that there's the idea is the cost on a per device level and address the technology because we're supporting the device lifecycle. So it ends up being a reoccurring model, and the way it deploys effectively is a SaaS or subscription model. Next slide. This is critical. Really speaks to the innovation of the platform. It really speaks to what is unique and special, and it's the dirt equation. Yes, dirt. God made dirt, and dirt don't hurt. But really, what we talk about there is these 4 pillars of trust. The fact that you need a platform that can describe behaviors, that can interpret machine-to-machine policy. It can rate the trustworthiness of that transaction and ultimately translate that into something actionable in being able to support, a requested operation. And from this perspective, you can really see Vault Core as being a policy decision point or a policy information point, depending on how it's deployed in the architecture. For itself, it absolutely is a policy decision point. And that becomes critical in a scale out situation for things like whether it's any sort of security object, public key infrastructure, which you're looking for like device identity, or even for smaller low-end infrastructure, symmetric cryptography that can be used in sort of a factory setting for device identities. Next slide. I wanted to, so look, this is actually a real world model of what we do in terms of how Vault Core is applied in these types of operations. And the idea being that there's a transition in industry where you can look at the fact that it's in times of yore, in the past, We would want to see cryptography would be applied at burn-in, and that would be the end of it. That would be, there really wouldn't be anything else happening. But with transitions, you see things like what Infineon is doing, or what Micron is doing with their Authentic platform. You really start seeing that their life cycle cryptography is becoming important, because it's also a way that the silicon providers and the folks that are supporting data in the factory are trying to move up market. And so technology like Volcore becomes absolutely essential to allow them to do that. And if you see the backup slides, there's some information about that in there. I won't sit there and waste everyone's time going down lower in the stack, but just know that it's there. I think the critical part though is you look at cloud services or 5G, which if you think about what 5G looks like from a service-based architecture, it is very quote unquote cloudy. You can start seeing that, well, there are a whole bunch of things that cryptography becomes important to be able to build trust. When we talked about the DIRT equation previously, so now we're going to talk about what that really means in application in terms of releasing cryptographic key material, being able to release security objects, in light of how that network is set up and configured. So this really helps drive that operational technology piece. Next slide. So this is something to note for, when we talk about semiconductor, programming infrastructure, the parts that Volcore is providing, and we also have this idea of a coalition of the willing, where we've brought on other partner companies where Volcore is sort of the foundation in which other technologies connect to provide those capability sets. In this case, the partner is Trustify. And what we're talking about here is this is a customer we're working with right now, where Volcore is actually doing the key management crypto services and supporting the PKI root of trust. So that's certificate authority behavior. And then it's interacting with that Trustify platform, which is getting into the programming component of the device. And Volcore is providing the policy, the controls, that authorization model, so that the Trustify solution is focused on, projecting that capability into the device. And in this case, what we were doing, it was to be able to allow for US sourced key material and management capabilities to be used globally for whether it's, semiconductor fabrication in the United States, or using consulting organizations for semiconductor manufacturing in places like Taiwan. So that sort of gives you an idea of what Volcore does in light of that use case. So moving on, next slide. So this is another implementation just to consider this in a secure PKI infrastructure. This is another partner of Phonetics we work with, is a Secure G, and they are building a scale-out PKI in which Volcore is effectively the enabling infrastructure to that scale-out PKI. And what we're doing here is actually this is an opportunity under the DoD 5G effort for smart warehouse operation, smart warehouse operations. So sort of that same idea for smart factory, but in this case, smart warehouse. And what you're seeing is for devices as they're being onboarded, as interacting with also 5G network, network repository functions as they're being enabled, Volcore is being engaged as a policy decision point for those operations. And then the audit data then can be supplied to a security operations center to see trends in behavior. We think about some of like the machine learning, artificial intelligence, and the conversations we've already had throughout the meeting, the presentations earlier, can actually mine that data for trends in behavior. So that sort of gives you an idea of what you think about from like whether it's 5G infrastructure or fabrication, key management, key lifecycle. You see where the platform gets applied. And so next slide. Here's one of our use cases. This is for a smart meter manufacturer in Eastern Europe, ADD Bulgaria. They are using Volcore appliances in both factory and supportive head-end units. So there's a transition from not just what's happening in the factory, but that life cycle handoff to the operational infrastructure. And that really demonstrates one of the things of why technology like Volcore is important, particularly as, when you think about what a smart factory is doing and how it's projecting its capabilities for not just for manufacturing, but when it gets into operations and maintenance. And so this is the idea where you look at how Volcore is being applied and how it ends up being used to be able to provide that end-to-end control of cryptography. This is
another 30 seconds.
Awesome. Next slide. Noting from a roadmap perspective, what you see here is sort of the idea of where Volcore is going in the future. And we're getting into data, content, and identity, and we're already projecting that way. And so the idea of building trust. Next slide. And then sort of another way to see that what you're ultimately seeing the end goal of our development, the exercise, what we're going to talk about in the final ask, is to build a OT SASE platform so that you could be able to enable this sort of orchestration in a factory setting and as it projects outside of the factory to life cycle. Next slide. And it's what we're looking for, 35 million. A lot of that's to build out that SASE capability as a SaaS platform, move things over. Some of it is aimed towards acquiring small companies that enable our capability. And then you see expansion in the federal market to continue that, what we're doing for our work with the Department of Defense and Intelligence community, grow our international deployment and support, and then continue to grow our channel, which has really been transformational for us over the past year in terms of like the relationships we have with companies like Dell, HPE, as well as other bars like WWT, and things like along those lines. What we're also asking for is partnerships, particularly to be able to grow that channel and those relationships because we do play nicely with others. And that's it. Thank you. Please feel free to reach out if you have any questions or want to throw them a walk-by way and say, Chuck, you have a pretty shirt.
Easy to say from sunny Honolulu or wherever you're based out of right now.
Indeed.
Yeah. Opening the floor to questions for our panelists.
You mentioned M&A. So, I mean, obviously, I think people want to hear more about the technology, but what stuck out to me is it wasn't a large allocation. The M&A market seems to be really overpriced these days. I don't know what you're looking for, but what do you think you're going to get for $2.5 million that's going to help you grow your business?
We have a small company or two in mind that we would be able to gobble up quickly and use that to project directly towards sales goals.
And what are those? And what type of companies are you looking for that would help you?
Either a company, what we're looking for is particularly companies with a services background, or being able to particularly do some things or continuing to maybe some controls around additional zero trust components, the data collection for us so that we can, better, project out policy execution points in a zero trust architecture.
Wonderful. Any last questions for Charles? All right. Well, thank you very much, Charles White, CTO of Phonetics. Thank you very much for your pitch. That finishes our second session of the event, focused on the smart factory or the brain, which enables, of course, the smarter side of Industry 4.0. In just a few minutes, we're going to go on to the next stage. But while we have everybody on the line, I thought just to take advantage of a few moments and the incredible caliber of panelists that we have here on the line, to ask a question to our panel. Can you each go over a technology or a company in particular, depending on whether you're government or if you're coming from the corporation side or the investor side, an opportunity that you missed out on that till this day you're looking at and saying, wow, I wish I had made that investment, signed that contract, or engaged in that partnership? Well, don't feel shy. Go ahead and jump right in.
So I'll jump in, but I'm going to redirect the question. So part of the problem in government is sometimes you see the future perhaps better than other folks within government, and our system is not necessarily agile. So you sometimes have to set the stage for something to happen, realizing that it's not going to be done quickly, but it will be done eventually. And I think that's what I've been trying to do really for the last 25 years is have that long-term vision, figure out the direction that we should be going, and then work towards that through all of the friction necessary to make it all work. So I would say that there are things that are out there that I think are still absolutely valuable, and we will eventually integrate those. We just haven't got there yet because the time may not be right, the money may not be right, technology may still not be where it needs to be for us to be able to integrate that. And part of it is telling the compelling story then that makes our senior leaders understand what we're trying to do and convince them that that's where they should reallocate the resources to make it work. So that's my thought.
Sure. Thank you, Ted. Thank you for that.
I was just going to say that I can think of a lot more deals that I wish I hadn't done.
I purposely did not ask that question. I didn't want to get into the shame game. Yeah, absolutely. How about Jen? Do you mind representing the city of New York and saying, what type of technologies would you wish would be integrated within the city?
Great. Hey, everyone. So it's actually not so related to like IoT and whatnot, which is kind of the theme of this session right now. But I lead our Moonshots program, and we're really focusing in on technology that can be utilized for financial inclusion and building community wealth. So it's a different kind of angle and may not be super relevant to this group here, but really looking for solutions on that front.
Fantastic. Thank you very much. Rose, can you chime in also?
Yeah, for us, I agree. What Ted said is really resonating with me as well. Sometimes it's really just the timing. It's not necessarily something that we wanted to bring in just because of the timing, and the stakeholders may be working on some other initiatives. But at the same time, it's actually a crucial technology that we need to bring in. We may not be meeting the timing of the investments opportunity in certain areas in logistics, but definitely we are a long-term stakeholders in this industry. So just keep pinging us and letting us know that where your progress is. Sometimes it just might take a few times talking and getting the right stakeholders in order to get on board and launch the products. And so if it's not this year, it's probably end of this year. So I think it's important for entrepreneurs to be persistent during this process. We meet, but then it also takes some conversations in order for a corporate to really go through some obstacles in order to really bring in the products to a larger market and adoption.
Very nice. It's interesting to hear you agreeing with Ted coming from a government perspective and Rose coming from a major corporation perspective, but with the kind of the same added insight on being persistent, even if the bigger organization has been slow on uptake. Destry, do you want to round us out there?
Yeah, I would agree with what both of them are saying. I mean, one of the problems is on the government side and probably on the commercial side, we pay as much for the bureaucracy as we do for the technology. And that bureaucracy burden ends up being on both sides as we move through the problem. I end up paying more in the long run. They end up having to take out of hide in the beginning as they try to get through the myriad of problems to get to us. With that, I mean, technology that comes through, I mean, it's one of the things we're trying to do right now. How do we get better with analytics? How do we bring in AI? How do we use ML? how do those things actually augment the force as a whole and stop thinking in stovepipes? We're very good at getting technologies such as tanks, but the thing that makes that tank unique has nothing to do with the tank. It has everything to do with all the systems that are attached to it and the architectures that build that. And so it's those underlying tools that are really important to us and making sure that we have the ability to actually bring in these new technologies to further enhance the capabilities. And I think those platforms are great. We spend a lot on them, but it's the things that go with them that we've got to understand exactly how we're going to integrate to them and how we're going to open them up in a cyber unsecure environment that we all live in now, and how we work through those things. So I think those are some of the things that are important as we move forward.
100%. So basically the rise of dual use, these commercial applications which have a potential cross application across Department of Defense, NASA, Department of Homeland Security, and other federal agencies. Absolutely. Well, thank you everybody for joining. Ted, Jacob, Rose, Mark, Jen, Charles, Destry, Todd, and also Karthi. We're moving on to our third session. So far, we've heard from an open topic and heard a really wide variety of technologies. And then we narrowed in on the smart factory, which was still pretty wide in scope, but as it related to what makes the factory actually work from a technical side. Now we're moving on, or I say from a innovation side, and now what we're moving on to is advanced manufacturing, the brawn, what actually is the backbone of the smart factory. Today we're joined by amazing panelists for this third and final session of our May Showcase event. Owen Meyer from Lockheed Network, Usako Group, from Usako Group Hahn, who's also on our first session. From Army Futures Command, Tim Crane. From GC International Group, Tina Tasakohoan. From Autodesk, Vanessa Sigurdsson. From Shimizu Corporation, Shutaro Kano. From Hexel Corporation, Robert Yancey. And from Pangea Ventures, Matthew Cohen. So I think what we could do right now is, while we have the investors and the corporations and government online, we're just a minute, we'll introduce ourselves. The lineup for the companies, we have ChemCubed, actually in this order, HES Global, Super Cool Metals, Peanut Robotics, ChemCubed, Newborough, and last but not least, Aqua Metals. So just opening it up right to the panelists. Panelists, please feel free to get online and introduce yourself. And right afterwards, we'll jump right into the panel. Sure, let's start with Robert Yancey. I think, Robert, I believe you're on mute.
Yeah, can you hear me now?
Yeah, perfectly.
Yeah, so Bob Yancey with Hexel, Director of Business Development. We're an advanced materials manufacturing company, and also have had experience in manufacturing over my career.
Wonderful, thank you very much. Vanessa, can you introduce yourself?
Sure. Hi, Robert. Nice to see you. I haven't seen you in a while. We used to work together. I'm Vanessa Sigurdsson. I'm with Autodesk. I am an industry engagement manager on behalf of the Autodesk Technology Centers. We have a space where we bring together startups, academics, industry to innovate for the future of design, manufacturing, and construction. And I focus primarily on the manufacturing side of things, managing some strategic relationships that we have, and really focusing on how can technology help to shape the future of manufacturing.
Wonderful, thank you very much. Matthew, can you introduce yourself?
Sure. Hi, everyone. Matthew Cohen of Pangea Ventures. We're a venture capital firm, and we invest in companies that are leveraging advanced materials and material process type innovations that can make a positive impact on the world. I'm based in Phoenix, Arizona, and we also have a physical presence in Vancouver, in BC, in Canada.
Awesome. Awesome. Thank you, Matthew. And Tina?
Hi, everyone. I'm Tina Tosuko-Wong. I'm a Senior Investment Director of GC International. We are the corporate ventures arm of PTT Global Chemicals, a petrochemical and material company headquartered in Thailand. We invest in advanced materials company, clean tech, biotech, life science, and we also invest in the fund. We invested in Pangea's fund as well.
Very cool. Very cool. Good. I like to see the synergies that we have on this panel. Is Tim Crane there on the line? Can you introduce yourself, Tim?
Hey, Josh. Nice to see you. Tim Crane. I'm the Director for Corporate Engagement at Army Futures Command here in Austin, Texas, where we are going after the modernization of the U.S. Army and all things that that entails, which includes a little bit of manufacturing. Great to be here. Nice to meet everybody.
Han Ko, are you still on the line? I guess not. We're moving on. Owen, are you there?
Yes, I am. Hi, everyone. My name is Owen Meyer. I'm the managing partner of Oikoi Network, and we're a B2B enterprise technology venture fund, and we're looking to invest in companies anywhere from Series A all the way to pre-IPO. We tend to be very stage agnostic, and at the same time, we are focused primarily in the US, and we're launching officially next month. And my background is I've ran a hedge fund for a few years, as well as worked in private equity.
Perfect. So that rounds out the panel. We get started with the first pitch. Starting off is HCS Global, led by Louis Borders.
Thank you. My goal today is to surprise you with what's possible in the world of automated fulfillment systems. RoboFS is an end-to-end hardware and software turnkey general purpose fulfillment solution. It's built upon AI and robotics. As you can see in the drawing, long conveyor runs, sorters, and mezzanines are eliminated. Next slide. The primary workflow of RoboFS is touchless, which results in a 50% lower cost of fulfillment than today's systems. RoboFS is productized and consists of 60 cells across 15 modules. Here you see the cells for the receiving module. Cells are factory built for lower cost, higher quality, and fast commissioning. With this modularity and the ability to daisy chain cells, we can meet a wide range of requirements and fit to a specific building size and shape. Next slide. RoboFS supports many verticals. It's ideal for a military supply chain with its fast deployment and redeployment capability. If you are a Global 500 company or a government agency interested in RoboFS, let us know. We have a priority rights program and are seeking 3 additional partners in addition to Toyota and Ingram, who've been partners for a number of years. Next slide. This is the first of 3 slides to show you how we automate pick and pack. First, we use multiple grippers across multiple pick stations and can actually pick more than the human hand. Next slide. Second, we have an interlocking tray system so that we can automatically organize items in trays by grippers. Next slide. Third, we move payloads 2 stacks of trays about 40 SKUs at a time by mobile robot to get high throughput and to get exactly what's needed at our pack module at the right time. Next slide. Our demonstration center, here is a sketch of our demonstration center. It contains the major RoboFS modules, and we'll now show the video, a video of equipment in action. Can you start the video, please? We start with the payload of coming into the receiving module. A payload is dropped off and an outbound payload is picked up for high throughput. And here's where we break down trays into compartments. They're singulated. For this demonstration, we color-coded the compartments. And you can see it's a jumble of compartments coming in, all different sizes and all different types of goods in them. Our tray maker organizes them by pick feature so that they can pick by the same gripper. And here you see a tray organized for picking by one gripper. A payload of trays is built for a specific destination. They're stacked, and in this case, it's going to our tray storage module. Our patented autonomous storage robot is called RoboFrame. It works both sides of an aisle. It docks the mobile robot so it can parallel process a payload transaction while putting away and receiving trays. Trays are gently rolled onto the shelves and stored 4 deep. All of the power in the system is in the factory-built RoboFrame, and shelving is non-precision so that our storage system cost is quite low. This part of the video is in our lab. Inventory trays come to grippers, and this is a jaw gripper being picking the goods. It would now go to the next station to pick smaller and lighter items. So we pick heavy to light and have picked with multiple grippers. Finally, once the orders are picked, the trays are stacked up, payloads are built, and it's sent off to packaging and loading. So next slide, please. We have raised $38 million to date and are now seeking a $100 million Series A, which is in line with the $38 million raised from partners. This will allow us to launch our e-commerce service in a full-scale $200 million capacity facility. In summary, RoboFS is bringing to the material handling industry a much-needed, touchless, 100% productized fulfillment solution. Thank you.
Thank you, Louis. Opening up the floor for questions.
Yeah, Louis, I think this is quite interesting, right? When we are talking about fulfillment center of the future, we know e-commerce is huge. But help me understand a little bit, the differentiation between what you have and what everyone else is doing out there in a very large scale. So the differentiation, and also when you have a fulfillment center, what exactly, who's your customer and how do they, use your service?
Well, our e-commerce business will be our first vertical, but this system is general purpose, so it's usable by Toyota for its manufacturing, Ingram for its large scale wholesale and retail, and e-commerce, now e-commerce operations. But to your question is, the differentiator, think of it this way. We think of it as there's 3 options for there's a lot of proven technology out there. There's shuttle systems, there's high bay systems, there's and so if you go with a proven technology, the problem with that is you're dealing with old technology, conveyors and sorters, high cost systems, monolithic systems. But they're proven and people are buying a lot of them. The second option you have as a buyer of a fulfillment system is a point solution. So you can buy, Kindred had a nice pick solution. Another company, Mir, has a nice mobile robot solution. You can bring those in and cobble that to your existing system. And the third option, I think we're by ourselves, and that's an end-to-end turnkey solution. It's productized. It includes hardware and software. So we use as our mental model, we use the iPhone. As if you build it as an integrated system with hardware and software, you have a tremendous capabilities and lead for a long time. And it's a very hard problem. People have spent tens of billions of dollars. It's a lot of pain out there. And we think this is a unique system. And 3 reasons we were able to do it. Great partners really guided us, Toyota and Ingram. 2, we took a AI and robotics approach and a hardware and software solution approach.
I have a question for you, Louis. It's a really great system. You had mentioned that there is some proprietary robotics around the platforms and some of the modular systems that you have. Do you see your company as a hardware provider or really an integrator of systems?
Our first business will be deploying RoboFS for our own e-commerce business, and then we'll be deploying it to companies Ingram and Toyota, our first partners, and they have priority rights for that. So we would be selling them a hardware and software solution, SaaS model. Maybe it's an infrastructure as a system model as well. We could probably offer both options, but we'll be delivering RoboFS to these companies. And it's great to have Global 500 partners. They need 20, 30, as many as 100 installations. I just want to add one thing about the partners. They've helped us so much, and that's why we want to expand it, but we just want a few more partners because they've helped us so much and guided us so much.
So my question for you is what is the exact commercial stage with regards to deployments, and are there any warehouses or otherwise that are actually utilizing your systems today, or where are you from a commercialization standpoint?
Well, we showed you a video of our demonstration center is just being completed and has all the main modules operating. Then we need to do our large Series A to do the full build out. But the risk of the automation, we think, is greatly mitigated with a full functioning demonstration center.
Wonderful. We don't have any time for more questions. I'm sure there are plenty of more questions for HCS Global and Lewis Borders. So thank you so much for your presentation, and hoping to hear more from you. Up next is Super Cool Metals.
Hello, everybody. Can you hear me okay?
Sounds great, Evgenia.
Okay, very good. My name is Evgenia Pekarska, and I'm the CEO of Super Cool Metals. And thank you very much for giving us an opportunity to pitch at today's event. Very nice to meet everybody. If you could go to the next slide, please. So most of you probably familiar with the Terminator and X-Men movie series. So if you combine the indestructible adamantium of Wolverine with rapid shape-changing abilities of Terminator, that's essentially the essence of our technology, Super Cool Metals. So we use materials that are called bulk metallic glasses that are 3 times stronger than conventional steel. They're 5 to 10 times more elastic than any metals and have a number of other unusual properties, and they can be shaped very easily. If you could go to the next slide, please. So we're targeting right now primarily robotics market, and I don't need to tell, I think the people who are on the call today, why and what. But because of the growing needs in the industry, in manufacturing, in service industry, and other areas where robots are used, the existing suppliers having a hard time keeping up with demand. And some cases, the lead time for components is up to a year long. And the cost of high precision gears is very high because of the very lengthy and expensive machining of high strength steel that's currently being used. So we are, yeah, you could go to the next slide, please. We are addressing both of these issues with our technology. So we have developed novel manufacturing processing methods for bulk metallic glasses called thermoplastic forming. And what benefits they bring is they allow up to 10 times faster production time for components, 30 to 50% lower cost with higher profit margin due to very easy and inexpensive manufacturing process, and lowering the cost of components will open new market for use of high precision gears. So an image, for example, at the bottom of this slide, so these parts can be made with forming without any machining, with very minimal post-processing with very high precision. If you go to the next slide, please. So right now we are producing high precision gears for NASA for flight parts. We are testing prototype gears with one of the largest suppliers of gears for robotics equipment. We have joint development with companies such as Raytheon and Move for different products. We're developing products for the Air Force and the DOE, and we have built unique equipment for thermoplastic forming of bulk metallic glasses at our facility. in Connecticut, where we are located. Go to the next slide, please. So how do we do this? So we start with a bulk metallic glass feedstock on a very simple shape. On the left-hand side, you see like a sheet type round feedstock. It is placed above the mold. I can't show you with the, oh, yeah, you can't see my mouse. But you see in the middle, it's a mold that resembles the geometry, exactly the geometry of the component we're trying to make and the specs. The material is heated, the process done in air. And once the material is heated, because of its unusual properties, it can flow very easily, like the Terminator movie, to replicate the mold precisely down to nanometer level precision if required. And it's done in less than a minute. So with this simple process, thermoplastic forming, you could create components of different geometries, very high precision, different length scales, different features and functionalities, which is very unique in terms of the metal, as far as metal processing goes. Go to the next slide, please. So right now, in robotics space, we develop in strain wave gears, which is the key component in every industrial robot. There are more than one of them. And we develop in other precision gears and bearings, and hoping that they could be used in the cobots in the service industry where low cost is required. In terms of other products in our company, we're also producing prototypes of propellant tanks, developing components for actuators and hardware for hydrogen infrastructure. And then further in the pipeline, we're looking into surgical tools and components for electric vehicles. And then the next slide. In terms of our competitive advantage, so we are the only company in the world that has expertise, IP, and capabilities to fabricate components out of bulk metallic glass and using thermoplastic forming processes. We compete, of course, with conventional materials, titanium, high-strength steels, and we compete, and benefits would depend on specific products and applications. And we compete with conventional metallurgical processing to make bulk metallic glass components, which have a number of technical challenges. So it's a very unique kind
Another
of
30 seconds.
Very good. Let's move to the next slide. I'll just tell you in terms of our robotics pipeline. So right now we're testing parts with one of the largest suppliers, and we hope to have production on the level of 50,000 to 150,000 around 23, 24. And develop the first plans for other products. And if you go to the next slide. So myself, I have a background in material science, and I spent many years in R&D before moving more on the business side. And I worked at Lux Research for almost a decade, evaluating startups for being on the other side. Our founder, Professor Jan Schwarz, is the world leader in bulk metallic glass processing. And we have a very strong advisory team, and I'll just highlight one person, Dr. Mohammed Zaidi, who is the former CTO of Alcoa, and who, under his leadership, was first aluminum Audi was developed a number of years ago. And if you go to my last slide. So we have brought in over $6 million so far in non-dilutive funding. And we're currently raising Series A, $10 million. And the plan is to further develop our customer base, expand our team, build equipment, and launch commercial production in the near future. With that, I will end. Thank you very much for your attention. I think I managed to fit in 5 minutes.
Great timing. Open up the floor for questions.
Yeah, I've got one. So I actually have two. So first of all, what are you selling? Are you selling parts, or are you licensing the technology to others to produce the parts?
So we're planning, right now we are producing parts, and we're planning to continue production for low to moderate volume areas, but we also building equipment, customized equipment, and in the future we also plan to sell our equipment for larger volume production so our customers can produce themselves through licensing of our technology.
Okay. Yeah, and then the follow-up question is that you mentioned you're competing against titanium, steel, and so forth. How do the material properties stack up against those materials in terms of mechanical performance and density?
So density of bulk metallic glasses is similar to titanium. It depends on the alloys. There are a number of alloys, but it's similar to titanium. But it's stronger than titanium alloys. It's significantly stronger than steel and aluminum. It is also very elastic. It's highly corrosion resistant, has much better low temperature properties, and a number of other things. For example, as gears, it can potentially run unlubricated as opposed to conventional steel gears. With better elasticity. So in general, these mechanical properties of bulk metallic glasses are superior to most conventional materials.
Okay, thank you.
Significantly superior.
Just to add that, can you tell a little bit more of your pricing and profit model? I wasn't quite sure about that one. Thanks.
Yes, very good question. So the material cost, raw material cost, is often a question because bulk metallic glasses are not as cheap as, for example, aluminum or steel. However, on the product level, and we have done a number of assessments for different products, the cost will be highly competitive and lower cost, as I highlighted for some of the areas, because of the very simple manufacturing process. So instead of machining for very lengthy periods of time, we just mold the components with very high precision. We can also mold much more complex components, for example, parts that require joining typically or assembly. We can all combine that into one step. We can form specific surfaces. So because of the aspect of the manufacturing process, the costs are expected to be lower in many cases, and definitely competitive in most cases. It is not though cheap material. So for example, if, components, very cheap components for automotive industries, cost pennies, that's not a good application for these parts. But for what we're targeting, it is.
Thank you.
Vanessa, I think you had the last question.
Yeah, I think on my end, this sounds like an amazing material. Don't know why my camera keeps freezing, but my question to you is, why gears? Are there certain types of products that this material is not suited for? And is this material potentially something that could be combined with a process such as additive manufacturing?
So this material is not suited for operations above 300 degrees Celsius. So any components that operate in hot, it is not good for because it will become crystalline and have the same properties as any other metal, but in fact worse. So high temperature performance is not good. Anything that requires very large parts, like for example, a part of an aircraft wing, this will never going to be used for. And in terms of additive manufacturing, we do not do additive manufacturing. Some companies have attempted to use bulk metallic glasses with additive manufacturing. So I think we can say we're really complementary. What we can do is not possible with 3D printing. For example, a hollow thin wall containers or components, you cannot do with 3D printing. We can make parts that would have no seams, very thin wall, very high strength, for example, that's needed for propellant tank, which can be done because of the size of the powder and other limitations of 3D printing. But in general, people have tried and continue trying using bulk metallic glasses for 3D printing because the material itself is such an attractive property. But our technique is good where 3D printing is not good.
Thank you so much for that. Panelists, for your questions, again, for your presentation.
Thank you very much.
You're welcome. Happy that you were able to join us. Moving on to our next presentation, led by Peanut Robotics. Joe is here to present Peanut Robotics.
So, Joe, can you hear me all right?
Yeah, can you hear me? Yeah.
Yeah, perfect. Is it all right if we start with the video and then I'll move over and do the presentation just because I have it separately, so it'd be easier.
That would be absolutely perfect.
Perfect. So let him bring it up.
I'll sort of narrate.
Awesome.
So we are a robotic janitor. This is aimed at commercial applications. Here, our robot is operating in a hotel room. This is basically a large hotel across the street from Disneyland. The robot operated for 2 months as part of the housekeeping staff. Here we are in a KFC, cleaning tables and floors and the bathrooms. Yeah, there we go, doing the floors. And the robot can go autonomously from place to place. All of the operations you see are autonomous. There is a training process. Yeah, here it is, the bathroom. And I think we've got a little bit more. Yeah, here we go. We've got some video of it operating in a co-working space. This is a co-working space in San Francisco. Yeah. And let me start by introducing myself. This is actually my third robot company. My first one was a company called Nita Robotics, which is the #2 robotic vacuum after Roomba. I did another robot that was acquired by a Taiwanese company. It's now doing elder care in Japanese nursing homes. And then this is my third one, like I said. So you can go on the next slide. There's a fundamental problem in cleaning. People don't realize this, but there's a huge shortage of cleaners, and it's actually getting worse and worse. This is a job people don't want to do, and the largest cohort in the workforce is of retirement age. They're retiring, and the people who employ cleaners have difficulty. They can't hire new people. They just can't attract people to this business. So let's do the next slide. So there are robots that do cleaning of large hard floors, like international airports and gymnasiums and convention centers, that sort of thing. And these are really popular, they're taking off, but this is sort of a niche cleaning application. Next slide, please. Really, most cleaning is things like a bathroom or hallways or a commercial kitchen area, restaurant, dining area. Next slide. As you saw in the video, that's exactly the sort of things we do. We're focused largely on dining areas and bathrooms and lobbies and entries right now, but there's a number of other things we can do. The robot can work fully autonomously, getting a work plan and working by itself, or it can work with existing staff. That's the case in a hotel where the robot's doing the bathroom while the housekeeping staff does the bed, for example. Next slide, please. This is a semi-public forum, so we don't have any announced partnerships, but we're engaged with actually the #1 quick serve restaurant company. We have 2 major universities who we're working with. We're working with a company called Tishman Speyer, which is a huge Class A office developer. We're working with hospitality cleaning companies on a number of fronts. Next slide, please. So the robot is aimed at cleaning, but that's not all it can do. The idea behind this is an autonomous mobile robot with an arm. We wrote it on a platform kind of basis. We have application software that does the cleaning. We have already been asked by various parties to do other things. One of the biggest questions that comes up is intra-building logistics, moving items from here to there. So, for example, there's a timeshare cleaning company which is asking us the question: can we move trash bags and dirty laundry bags from out of the hallway to a central area? And of course, we can do that, and we will do that. Maintenance things
another 30 seconds.
Anyway, there's a number of other applications that are available to us as well. Next slide. So what we're seeking, so we have a phase 1 AFWERX MOU. I don't think anyone who's left on the call is Air Force, but if there is someone from Air Force, we would love to find someone for MOU for phase 2. And we're looking for partnership, and we're looking for investment. Next slide, please. Yeah, I've gotten through the whole thing in 5 minutes. I mean, this is a consistent, cost-effective solution with a really terrific customer pipeline. Yeah, that's us. Any questions?
Okay, Joe, I need that from my house if it can. I'm so well, joking aside, right? What do you need to raise in order to go to the next step in securing customer and what exactly, how are you going to deploy it? The robot cannot go upstairs, downstairs, right? Is it like they buy the operator, or do you take it to the site, somebody maneuver the robot and charge it at the end of the day? How does it actually work?
That's a lot of questions. So first of all, I want one in my house too. I'm dying to do a home version. I mean, I've done home robots before, but we're starting with commercial because of course the money is much larger in commercial and it's expensive machine right now. But cool metals might help us make it cheaper. The robot does not go up and down stairs, but it can ride elevators by itself. So that's the kind of environment it expects. Yeah, the on-site people, the existing cleaning people, have to refill the cleaning fluid, change the cleaning pads, and it has actually replaceable batteries like a cordless drill does. So it can run indefinitely. The robot's not stuck at a charging station while its batteries are charging. The batteries charge while the robot works, but it will operate 6 to 8 hours on a single set of batteries. So it can do at least half a shift. We've just increased the battery capacity. We're hoping to hit a full shift. We don't know yet whether we are. What other questions did I miss? Oh, what do we need? So actually, our plan is, we're just a seed funded company. We're very small. We don't have a customer problem. Customers are clamoring for the solution. We plan to raise a large Series A in the next 6 months, but we actually are just looking for some bridge funding, $1 million or $2 million, to bridge us to that time, is what we're looking for right now. Although if someone wanted to go lead an A right now, we would be very interested. But we feel like people are going to want to see us develop these customers a little bit further.
So, a question here. So, what's the status of your product development again? Your status of your product development.
Yeah. So the product, we've done demonstrations in a number of different sites. I could show you a much longer video with more sites, and we are now entering formal trials, which will lead to paid deployments.
So I'll jump in. Oh, sorry.
But go ahead. That's fine.
Go ahead, Hahn.
No, go ahead. That's fine.
Okay. I'm glad that you're coming at this from the approach of this is a sort of a human assisted device, or it's there to assist the jobs of a human that's potentially there to do the more nitty gritty type work and take care of things in advance. Piggybacking off what Tina said around sort of logistics, it seems like there's a lot of potential logistics to take into account. Where will this device be stored when it's not being used? But also I would imagine there's sort of, the education required to train somebody how to use this. There's the maintenance that will probably need to go along with it. Have you considered maybe applying this to, instead of a commercial application, but an industrial application where maybe there is personnel that is kind of more at the ready to take on that learning or be able to use the equipment?
So I'm not against doing industrial. Were you imagining the cleaning application, or were you imagining a different application?
Yeah, I'm imagining like really dirty, manufacturing sites, for example, that need things to be sort of cleaned on a regular basis, where there's potentially personnel that is already skilled enough to, maintain the equipment, just as a place to kind of proof out the concept some more.
We've had no exposure to those applications. That sounds pretty interesting, actually. Yeah, the biggest challenge that we've had has been around those questions. The plan is, the questions of training people and how do we make it so that it fits into existing workflows. We've done a lot of work around it. We think it's going to be okay, but that's really going to be the focus of the trials. But an industrial setting has those benefits that you described. So yeah, that's interesting.
All right. Thank you very much, Joe.
Thank you.
From Peanut Robotics. We're going to move right on to the next presentation, Chem Cubed, led by Daniel. Hi, Daniel.
Hi, can everybody hear me okay?
Yes.
Okay.
Great. I'm Dan Slepp. I'm the CEO and founder of ChemCubed. We are a research and development manufacturing company for materials for additive manufacturing. I've been in the field in the printing field and coatings and nanocomposite field for almost 30 years now. Basically, we started ChemCubed around 6 years ago, recognizing that there's a need in additive manufacturing for specific materials, and the off-the-shelf materials right now in additive manufacturing and 3D printers and such would not suffice. Next slide, please. We realized in our research in the last, at the beginning, is that there is a humongous gap in electrical manufacturing of PCB boards, including flexible electronics, regular rigid boards, and flexible hybrids. So we've went ahead from a materials point of view and started developing some materials to cover this gap. At this point, I should say why we're pitching here. And we just won a phase 1 award for AFWorks, and we are looking to get an MOU with a Air Force partner or Air Force customer. We're also looking to expand our innovation and our technology and a lot into marketing, which I'll go into in a minute. So the problem right now is that the current technology of PCB board printing is not widely adapted, only for maybe some rapid prototyping. Next slide, please. So what we've despite just our materials, or including all our advanced materials, which I'll get into in a minute, we've developed some advanced printing technologies and commercialized it. We've had tremendous success with our printing on multiple surfaces and printing circuit boards, multi-layer circuitry, using a printer that's built specially for us, using our materials. We've recently signed on about 8 reps across the country in the U.S. We've got distribution now in the Asia Pacific Rim, and we do have printer sales out in Europe. So we've got about 20 plus of these printers out there. We have more printers than our nearest competitor. I'm going to also say that our nearest competitor printer cost is around 10 times the cost of our printer right now. But again, where there's this gap, the printer is a standalone printer. It's great for prototyping. And what we're looking to do is to advance the printer to make it a little bit more usable in a full production line. Next slide, please. But what really stands us apart and what we are mostly is a materials company. We've originally developed some silver conductive ink that, there's a lot of silver conductive inks out there. Ours is a nanoparticle free ink. It has near bulk resistivity, centers at very low temperatures, so it could go on multiple substrates. With our printer, reliability of circuitry is down under 1%. I'm going to say that we've had our inks evaluated by numerous customers in aerospace and automotive. We have these printers are bought by some automotive companies and second and third tier companies to the defense. And we are currently actively working with Boeing And Boeing is interested in being a phase 3 customer when we get there, and have some other proposals in different areas for the government, where Boeing is taking the lead with our technology. One of the
30
other
seconds.
That's fast. One of the other items we have that's very important is our dielectric inks and insulating inks, which allows which is completely compatible with our conductive inks, and that's what allows us to do multi-layer printing of conductive circuitry. Next slide, please. And we go through a number of different applications and what this printer is being used for, including IoT. You can see the flexible hybrid and displays and packaging. Wearables are big, and we're now beginning to get into the semiconductor manufacturing industry as well. Next slide, please. What we're looking to do is build a full system from beginning to end in our AFWorks proposal to upgrade our printer and putting it in a full manufacturing line. So if there's any Air Force people here, we would love to hear from you. But we're going to be putting an end-to-end manufacturing line from our collaborators using different types of new SMT technology, which is component placement technology, which will goes at low sintering temperatures as well. So and is extremely flexible. Next slide. So we do understand that there's a tremendous defense need. We just need to get to the right people under security, perhaps for replacement parts, and increasing the lifetime of components and equipment.
And maybe you can round up and finish up with your ask.
So so what we're asking for is partners to expand our marketing, add a lot more, a little bit into our engineering, and bring our printer to full production capabilities.
I think you also mentioned maybe some MOU partner for Air Force, and then further contracting opportunities with the government.
Yes, we are definitely looking for our Air Force partners.
Wonderful. Okay, open up the floor for questions. Any questions for Dana from ChemCube?
Hey, I'll just throw this out there. It's not necessarily a question, but I'll look forward to a follow-on with you if you don't mind. I'm not from the Air Force. I am from the Army, but we are looking for similar materials, or at least advancements in similar materials for our aircraft. I almost feel the need to say that we have more aircraft than the Air Force, but I'll refrain on inter-service rivalry for the moment.
Well, I definitely would look forward to.
I'm happy that you refrain, though.
Yeah, almost refrain.
A partner that you might want to consider looking to is Oak Ridge National Labs. They have a manufacturing demonstration facility in Knoxville, Tennessee. And if you don't have a way to connect with them, I'd be happy to pass along anything that you'd like to send over.
I would love that. I'd love to be able to connect, send you something, at least my contact information for you to.
Yeah, they're DOE, but you know, I don't represent DOE at all, but we do work with them as well.
I would appreciate that. Thank you very much.
You're welcome.
For your initial iteration, at least with where things are today, is there kind of like a production volume sweet spot that you'd be targeting? Is it, you know, one-off devices, 10, 100, 1,000 PCBs, or something in between?
Right now, we have a proposal with Boeing to manufacture an IoT device, about 400 units within a given amount of time, a few days. So once we get the whole end-to-end system up, we're supposed to be doing about 400 units. So we are looking for small manufacturing, more than just rapid prototyping. We think that the capability and the cost is so low compared to actual PCB board manufacturing, where you're and it's extremely sustainable because you're not doing any sort of copper etching, and the design work that you could do is going to be isn't as limited as it is with normal multi-layer printing. So we're looking at trying to bridge the gap to true industrial applications.
Quick question on, the end product, Danielle. Is it sort of like 5G ready with, the fabrication like this? Is it like really, really smooth? No signal attenuation or?
Right now on the printing in the printing area, it is very smooth. When we place a printer right now, we actually have the end user up and running within the day. With just a little bit of training, we do it virtually. We do have a service person there for people who want to have it installed for them and trained there. But within the day, they're up and running and are able to run their production lines and our R&D facility, whatever they're using the printer for. So I'm going to say that part of trying to expand on the printer is to have it put in some fiduciary camera systems and try to upgrade the printer slightly.
Thank you very much, Daniel from ChemCubed. We're going to move right on to our next presentation. Second to last is Newborough, joined by Mark Zedeker.
Hi, Mark Zedeker. Nice to meet everybody today. And we're going to talk a little bit about Newbrew and how it's now moving from its initial company stage of introducing blue laser technology to the industrial markets and moving those lasers now into additive manufacturing applications. The company was originally founded with additive manufacturing in mind, and as a consequence, has established a significant patent portfolio around this technology. Next slide, please. Biggest question we always get is, why is blue important? Well, this is a very simple chart to show you that in the infrared, the absorptivity of materials is very low. And as you go to the blue, the absorptivity of material is very, very high. Because of this, we've had tremendous traction in the markets of manufacturing of batteries. And we've also had a number of defense applications where this is important as well. And what we're doing now is applying this into the additive manufacturing space and getting remarkable results to date using powder bed type additive manufacturing machines. We get better surfaces finishes, we get higher densification, we get far, far better parts produced than you can produce with an infrared laser. Next slide, please. We just started doing a fair amount of testing in powder beds, and in this case, we've integrated our blue laser into an EOS M100. This is our first test with stainless steel. We have similar tests done in copper. Parts were fully dense. Tensile strength is currently under test. We see an improvement in surface finish. For the given amount of power that we had at the time, we were running 30% faster at half the power of the IR laser that the system came with. In addition to that, with copper, we're showing greater than 95% part densification right from the machine without having to do any kind of post-processing like hot isostatic processing. The system at the time from EOS was incapable of printing copper, and we've now converted it over to our machine. We've been very successful at copper and aluminum in this machine to date. Next slide, please.
I'll pull up the video.
Yeah, that'd be great.
Metal 3D printing has been plagued by slow production speeds and performance limitations. Imagine a solution that delivers full metal density, small features, no post-processing, and a production speed that's 100 times faster than traditional powder beds. Enter Print Blue, developing HD area printing with advanced blue lasers. The technology is based on the following principle. A blue laser is imaged onto a digital light modulator with 2 million pixels. the light-modulated image, is projected on a powder bed and melts a large area of the powder layer with extreme high resolution. A step and repeat process completes the powder bed layer. And successive layers of powder are added and printed. When compared to traditional infrared-based 3D printing, area printing can produce parts at a speed that is 100 times faster. Blue laser technology enables this new area printing method for metal parts, providing a step and repeat process with extremely high-speed printing and ultimate efficiency due to high absorption in the blue. With the increased production speed, metal 3D area printing becomes a much more cost-effective solution for precision printing of small and large parts alike. Delivering full metal density without any shrinkage, small features, little to no additional post-processing, and 100 times the speed of traditional powder beds. To learn more about how Nuburu's Print Blue technology is transforming metal manufacturing, visit www.printblue.com.
Thank you. On to the next slide, please. So this was just a very quick analysis we did. We've actually demonstrated the process that was shown in the video. And what we can see here in this chart is that we can scale this to very large sizes with very high build rates and very, very cost effectiveness. Next slide, please.
You have another 30 seconds.
Great. Nuburu, because it started filing patents back in 2012, has 37 patents granted worldwide, including 2 landmark patents. One is for using a blue laser to weld copper, and another one is for additive manufacturing with blue lasers and how to build blue lasers. Next slide, please. Market traction, we have lasers all over the world. We've received awards for our technology, and we continue to expand our applications in the industrial space. Next slide. We're a highly experienced team. We're currently in the middle of our Series C raise. Next slide, please. We're looking for partners to provide funding for developing this Print Blue technology. This is the second stage of the company, and we're looking for up to 50 million in a Series C raise or non-dilutive funding to help us with developing this technology. Okay, next slide. As I mentioned here, we're founded in 2015. We got about 30,000 square foot facility in Centennial, which includes engineering, manufacturing, and applications development. And we've just dedicated a new additive manufacturing lab. Thank you very much for your time. Any questions?
Yeah, so Mark, great presentation. So do you still have the typical process that you would use for powder bed fusion, where you need to have a build plate, you might have support structures that you need to remove after the build? Anything different with your process in regards to that?
Yeah, because we're using a much lower power density, you still have to have the support structures, obviously. And depending upon how you do the powder spreading, you also have to consider support structures, especially when dealing with overhangs. However, because we're using less power densities, the binding to the build plate is less strong, I guess is the best way to describe it. Okay. And it's relatively easy to remove the parts.
Okay.
Can I, along the same lines, can I ask about the overlap when it comes to each of the sort of digital images that are projected on the part? Do the images overlap, or do they just literally align perfectly? And are you finding any issues between the divider line between those?
Yeah, actually the video doesn't quite show exactly what we did. It's actually a continuous print process. So as a consequence, there's no issues with overlap. But it does print an area at a time, not a single dot.
Yeah. Very cool.
How would you compare the price to the other conventional the method?
The price of the machine or the price of the parts?
Both.
So the slide I showed the price of the parts, and you can see a substantial advantage, especially in the materials that are highly reflective in the IR. But we still show price competitiveness in the stainless steel and titaniums and things like that. In terms of price machine, it's on par.
Thanks.
Yeah, and then since you're using lower power density, do you have less issues with warpage?
Great question. Not only less issues with warpage, but there is no spatter. So there's a substantially reduced defect incorporation rate into the part. We're actually using a
I could also see another selling.
What?
I could also see another selling point to this being the sort of energy efficiency of the system. Would you say that there's sort of a sustainability component to this?
Yeah, the blue laser is so highly absorbed by all the materials, it takes a lot less energy to do a process. And that's one of the reasons why the area printing works with the blue laser, is because you simply do not have to put a lot of power into the part to do the job, which of course reduces the part warpage that Robert brought up. So yes, there's a huge energy efficiency aspect of this.
So Mark, could you, oh, okay. We're moving on, that's fine.
That's okay. You have question. I'm queuing it up. Ask your question.
Yeah, commercial timeline. When will you be in the market selling machines?
We will be in the market next year with our first blue laser additive manufacturing machine, which will be a powder bed based machine. It will not be this that we just described here. It'll actually be a simpler design based on the conventional F theta lens and scanner assembly. But this system is about two years out.
Wonderful. Thank you so much. We're going to move on to our last presentation of the day. So that was Mark Zedico from New World. And now we're moving on to Aqua Metals.
Great.
You there?
Yeah, I am. Thanks, Josh. I'm Steve Cotton, President and CEO of Aqua Metals. We're a NASDAQ listed public company. Call letters are AQMS on NASDAQ. And I'm going to tell you about what we're doing for the battery industry and leading really a revolution in the battery industry, starting with lead and then moving on to lithium ion and other metals. Next slide. This is just our safe harbor. You can refer to that in the future. I'm not going to read that to you. Next slide. So what we're really doing first is changing an industry. The number one most pollutive thing that mankind does on Earth is to smelt. And this is an example in a picture you see to the left of the old way and the incumbent way of recycling metals from batteries. And smelting is used in many other industries. It's a very dirty, very dangerous, and highly emissive process that operates at furnaces that are 3,000 degrees or even more, and causes a lot of challenges. Even though the good news is you're recycling, the bad news is you're exposing workers, the community, landfills, and the air and emissions with problems. So you convert that to what we offer as the next slide. This is called aqua refining. What we do is we build lead one atom at a time through a continuous process with rotating discs that go into a room temperature organic biodegradable acid. And we digest from the recycling process into that acid the lead content in this instance, and then we plate out at a very specialized level through our aqua refining process, one atom at a time, ultra pure metal. So it's very novel compared to what you see from the Bronze Age. Next slide. This technology isn't lab or bench scale. It's been commercially demonstrated. We built in the Tahoe Reno Industrial Center a 140,000 square foot facility and demonstrated our technology and made 35,000 ingots. And we shipped those to the world's largest battery manufacturer, Clarios, who is also an investor in Aqua Metals. Clarios used to be Johnson Controls Power Systems division. You'll see those ingots pictured on the left, and because of the ultra pure metal that we make, they're the finest looking ingots in the $65 billion lead battery acid manufacturing industry. Next slide. So AquaRefining creates that higher quality product, and because of that, there's little to no refining needed. You can see the lead spilling literally behind me, as well as on the slide, off of the plates and then down onto a conveyor belt to get compressed into briquettes. And it ultimately means that you can create much higher performance, much longer lasting batteries, recycle with a very minimal need to refine and at an equal or lower cost, and allows the existing recyclers that are under increasing environmental pressures to meet that demand as we go forward into the future. Next slide. We've really paid attention to our IP since the inception of the company in late 2014, and we have a global portfolio of IP that's really focused on materials and methods, inclusive of that continuous rotating disk process with that biodegradable room temperature electrolyte. You'll see the map legend down in the lower left that shows where we have approved patents and patents that are approved and as well as pending in the lighter blue that covers the globe pretty much everywhere that you'll see smelting. And there are about 300 lead smelters for our first application of AquaRefining that are out there in the world that are targets for us to upgrade. And you can take this technology and bolt it on to existing facilities as well as deploy it to greenfield facilities. So that IP portfolio is very important. Our business strategy is really, now that we've demonstrated the technology, is to be an IP licensor as well as an equipment supplier of the equipment like you see behind me and you saw in the prior slides. Next slide. So why does AquaRefined lead matter? Some people think lead's dead. It's actually not the case at all. The energy storage industry is growing at leaps and bounds. Lead is the mature industry. Lithium ion, which we'll talk about in a minute, is a growing industry that's going to be adding to the capacity of the world in terms of gigawatt hours of storage. Things that are driving lead acid battery growth is we're putting a lot more cars on the road, particularly in developing countries. And if they're electric vehicles, they have lead acid batteries in them for the most part that don't last as long. In fact, yesterday I replaced the 4th lead acid battery in my 2015 Tesla Model S. They also have 2 batteries in them many times for the start-stop, in addition to the SLI, start, light, ignite, to start the engine to begin with. Solar, wind farms need battery energy storage, else you're taking energy that's created from clean processes and electrocuting worms because there's no place to put it if nobody has that peak demand at that moment in time. The industry that I came from, which was lead acid battery monitoring, which is in the data center world, which is, for example, enabling this type of experience in a conference, has massive server farms backed up by massive battery farms. So when the utility fails, they have a bridge to get to the generator power, which are also started by batteries. And so there's a driving need for demand for stationary applications such as that as well. The lead industry is growing at about 3 to 4% cumulative annual growth rate. The lithium industry, in comparison and contrast, is growing at about 38%. And they're going to be about equal size in terms of the recycling industry by about the end of the decade. So let's move on to the next slide.
Another 30 seconds.
So Aqua Metals' position for impact is really that we're the first of our environmentally friendly kind of technology. We've got $200 million invested, and we're going after a $20 billion market just with lead and double that with the lithium. And licensing discussions and equipment supply discussions are well underway. Next slide. We're driving a new clean industry with the lithium ion, and we're building on that proven IP. We filed provisional patents. We've established an eco-network of multi-company partners to tackle the clean lithium ion battery recycling world. And that is going to be beginning in early 22 at the Tahoe Reno AquaRefinery, which is now owned by a company called LiNiCo, stands for lithium nickel cobalt, which we intend to have utilize our technology to recycle lithium ion batteries in addition to lead. Next slide. This is our revenue path. We were founded in 2014. We developed the technology. We went into revenue in 2018 and 2019 and sold millions of dollars worth of lead from our technology. In 20 and 21, we're focused on the transition to the capital light equipment supply and licensing of our technology, and then getting revenue as we go into the future off of the equipment supply and licensing technology for lead as well as lithium. Next. I won't go through this in detail. Experienced management team and engaged board is focused on execution. We all come from the metals, mining, lead acid battery, licensing, energy industry. Our chairman of the board is a non-executive chairman for good corporate governance. Shark Yousafzai was president of global marketing at Chevron in one of his many roles at Chevron. Next. So what we're seeking is we're always interested in public-private partnership. We believe energy storage is the critical path to a sustainable future. You can't have a sustainable future unless you recycle it, the materials. The lead industry recycles, but it makes a mess of it. We're cleaning that up. The lithium industry, it doesn't recycle currently, and we're aiming to create a recycling ecosystem of a clean methodology. So those lithium-ion batteries are things that we can feel good about using. And also create a sustainable world for the future for our children and grandchildren. If you look at what we're interested in specifically, those are things like grants for research and development, government-backed loans, not only for ourselves. We did get a USDA-backed loan for Aqua Metals to build our plant that we ultimately did a $10 million loan coupled with our IPO to fund the building of the plant that we then paid back. But we're looking for government-backed loans for other activities, which could be inclusive of supporting our potential clients that want to take the risk, that have large operations, that we want to keep strategic metals and things like that in the US, and we would like to support our potential clients and connect them. We're looking for additional eco-network members, producers, and users of spent lead acid or lithium batteries will be pointed to in terms of where is the recycling happening and is it clean. And so we are trying to get others to join our eco-network of companies that are developing and deploying these technologies. We're looking for access to the feedstock as a part of that to recycle, and offtake buyers of cleanly processed high purity metals really from our licensees and operators of our equipment. So with that, I think I conclude.
Thank you, Steve. Any questions from our panelists?
How much, if any, additional kind of technical development work or just adjustments compared to recycling lead is needed for moving to lithium ion?
So lead is a single metal battery recycling environment. The nice thing that makes lead acid batteries so fungible is they're about 80% plus of the lead in a new battery is recycled versus from the mine, and the other 20% or less comes from mines. In a lithium world, you've got lithium, nickel, cobalt, manganese, et cetera. We will be taking the cells like the one you see behind me and adapting the chemistry a little bit and the technology towards very similar looking cells that will focus on each type of individual metal. And we'll be deploying those in the LiNiCo, lithium, nickel, cobalt recycling facility right here in Tahoe, Reno. And so it will look like what you see behind me, but the metal that comes off will look a little bit different for each type of metal, if that makes sense. I'll add to that that's why lithium batteries are so difficult to recycle, and nobody to this day has commercially proven that you can actually recycle lithium-ion batteries to anywhere near the percentage levels. Lead batteries are recycled 99% by weight. So being able to go after the multiple metals and solve that type of environment is more complex and does require a core fundamental shift change in the technology. Some are going after the lithium industry for recycling with a process that I started with called smelting. And let's not build a world of smelting that's even worse than the lead smelting world.
Question here. So do you have any advantage in certification or regulatory process in recycling material?
Oh, absolutely. So if you look at the regulatory environment here in the US as an example, as well as Europe and China, really, the regulators as well as the Court of Public Opinion are shutting down smelters left and right. And they're being shut down because of environmental emissions. As I said, it's the #1 most pollutive thing that mankind does on Earth. A long time ago, many of these smelters were built far away from everybody, and then the urban and suburban infill happened around these places. Plus, we've realized that these emissions are problematic. Our process has orders of magnitude less emissions, as you can imagine, because it's liquid-based, it's biodegradable, organic acids and things like that. So the regulators love what it is that we're doing. So we're also, of course, talking to the various regulators like EPA, in the US and other regulators throughout the world to make sure that we are considered for best available technology status. So when these facilities need to expand or new facilities need to be built, that's what happens. Another instance is when we're in India and Southeast Asia, where you see a lot of growth in automobiles and battery energy storage requirements. China has cracked down, and so they have pushed the manufacturing of batteries as well as the recycling of batteries out to Southeast Asia and India, associated with that demand. And the governments, when they go for the greenfield builds, do not want to build smelter facilities that make an even bigger mess of the environment than they already have in their hands. And so we're seeing quite a bit of public-private partnership in those countries. And what we're seeking more of is right here in the US, public-private partnership, because of the regulation factors, but also in order to keep strategic metals in the US, as we all probably know, you can't get many of these metals like cobalt, for example, comes from the Congo. It's very difficult to secure a green energy future in the US if you don't have secure minerals to put into that and to recycle into that. And so the technologies that are developed here in this country are, to me, just as, if not more strategic than the inception of the oil and gas industry and the seeking of energy independence for our country. This is just as important if we're going to have energy independence on an ongoing basis, and if we're going to have green energy storage that's a truly recyclable energy storage for our future.
Right. Actually, I echo that because a lot of these growing emerging market in Asia, they're a lot more conscious about environment. So you have a very, very good selling point right there. Yeah. Maybe we can just connect offline later. Thank you.
Yeah, sure. Absolutely. Happy to.
Hi, Steve. I mean, this lithium-ion battery recycling is really hot, right? There are so many startups raising a big round to develop the technologies. Can you comment on where you are in the development stage, how you compare with other lithium-ion battery recycling startups?
Sure. So there's some that you're probably referring to that have gone out via SPAC, special purpose acquisition company, become public companies that way. They have various technologies. Some of them are using smelting as their core technology. So they're talking about lithium-ion battery recycling, which gets people excited. But if you do the due diligence of what the impact of the planet and the workers is, it's not very good. And so the ones that are doing the smelting, because smelting has been around since the Bronze Age, they have operations and are operating to a very small extent to date. There are others that are doing hydrometallurgical. But if you ask those entities that are worth $1 billion plus on the stock boards, what IP do you have? The answer is usually none. It's trade secrets. You compare that to Aqua Metals, we have IP, and we filed further IP as it relates to the specific metals within lithium-ion recycling. If you ask them what their cash position is, it's usually not a very good answer. If you ask them what their access to ongoing capital is, it's new and fresh for them. If you ask them what their track record is in terms of what have they done to prove that they can do lithium-ion recycling, I feel that the answer is not as strong as what we have with Aqua Metals, because we've already built and demonstrated for the world's largest battery manufacturer the core technology and sold battery ingots that they make batteries out of that went into Ford, Toyotas, and GMs and the like. And then we also, because we built that aqua refinery that is now at the Linico facility that's in Tahoe, Reno, there is today a 140,000 square foot facility sitting on a piece of land that's getting outfitted and will become operational later this year and into the early part of next year. So on a timeline perspective, it's way ahead. And then the last point I would make is there's these other companies tend to want to go it alone a little bit. And we have a view of an eco network. And so our eco network is Aqua Metals, Linico, the operator, which we made an investment in, Comstock Mining, which is also another public listed company, made an investment because they're transitioning to more of an environmentals and metals recovery and valorization of metals type of a company. They're in there, and there's others that are in that eco network that is supporting, and we believe that it's going to take the brains and brawn of multiple companies to truly stand up the lithium-ion battery recycling industry. And that's the approach that we're taking and have taken from the get-go. We feel like we're pretty far along comparatively.
Thank you so much, Steve. Excellent presentation. In the last of the event, so well done. We're gonna leave it on a bang. I want to thank everybody who pitched, the companies that pitched today. We had HTS Global, Super Cool Metals, Peanut Robotics, ChemCubed, Nubaru, and last but not least, Aqua Metals. Great companies, really interesting to see a variety of raw or advanced manufacturing companies to complete the Industry 4.0 event. I just want to thank our incredible panelists throughout the event, but particularly on this last session. We had Owen Meyer from Ohio Network, from Isako Group Hanko, Tim Crane from Army Futures Command, Tina Tazako Wang from GC International Group, from Autodesk, Vanessa Sigurdsson, from Shimizu Corporation, Shintao Okano, Hexo Corporation, Robert Yancey, and not last but not least, also here, Matthew Cohen from Pangea Ventures. Thank you so much. You really added a lot with your feedback, with your questions to the companies. Please stay in touch. Please feel free to interact with these incredible companies and encourage the companies also to interact with these incredible panelists. So thank you. Have a great rest of your day.